Today I would like to show and share about how to back up and restore multi-panel MP277 10-inch using LAN cable. Yes, here is the multi-panel 277 10-inch touch panel. Yes, and this is a software schematic flow cell version 14.0.10, and I will choose the LAN cable for connect from my PC to the multi-panel. Okay, so first let's go to our software. Yes, so here is the software ProCell schematic flow cell that I already installed in my PC. So first let's go to open, and then we'll find the multi-panel. Yes, MP77. Yes, MP77 10-inch touch, right? So MP277 touch, right? This one. Okay, and then we will choose the Ethernet cable. Yes, so choose the Ethernet and then choose the IP address. Yes, this is the IP address of the touch panel that we already configured in the touch panel. So we can ping, yes, 192.168.0.2, right? Yes, and then enter. So right now we can ping from the computer to the touch panel and show the status we can communication. Yes. So first reboot the touch screen. Yes. Wait a moment for reboot the touch screen. Yes. Because it will take time little bit for rebooting. Yes. Yes. Okay, and then we go to control panel, and then go to S1 transfer sharing, and this one we need to select to property. Yes, because we need to set the IP address for the HMI, otherwise we cannot communication between our HMI with the computer. Okay, so right now I will set IP like this, 192.168.0.2. okay, and subnet mask 255.255.255.0. okay, and then click OK. Yes, click OK again, and here is make sure we select the S7 Ethernet for transfer the data. Yes, so click OK. Yes, and then click OK again. Yes, and then click transfer. Yes, and we will transfer from the computer, or we can back up from this screen to the computer also. Okay, so make sure we change the setting to Ethernet, and then we click the transfer. Okay, so first go to the backup tab and then choose the browse. Yes, example MP backup, yes, BK, yeah, like this. So click open and then choose the backup, yes, and then start backup, yes. Take time a little bit for backup the screen, yes. It will back up all the program or screen that has in the touch panel, yes, to our computer. So wait a moment, yes. It takes time around 2 to 3 minutes for this backup, yes. Yes. After that, we will check again, and the touch screen will automatically reboot. Yes. Actually, we can use the USB cable also. I mean, convert from RS232 to USB, and then we can do the backup also. Okay. I will show in the next video about how to back up the touch panel by using the ProCell version 14.0.1, yes, and we can also restore the touch panel also. Okay, so wait a moment for the backup. It will automatically reboot the screen after this backup finish. Okay. Take time a little bit, around 2 to 3 minutes, yes. Actually, when we install the WinCC flexible, it will have the schematic ProCell, yes, by no need to manual installation. Okay, so right now it already back up the file, yes, and here is the file backup, yes. Can see the property 63.2 megabyte, yes, and this is a file extension .psb, yes. And if we would like to restore, yes, we can go to here, open, yes, and then choose this also, and then internet also, and IP address, don't forget, and then go to restore tab and browse the file, yeah, example this file that we already backed up, yes, and then go to the restore. Okay, yes. If we don't click the HMI, it will show alarm like this. So okay, right now I reboot the panel, touch panel. Waiting for reboot, yes. Yes. And and then go to transfer again. Yes. And then click the restore again. Yes. Start restore again. It will restore the file that we already backing up. Yes. To the touch panel. So it take time also for this one. Yes. Wait a moment. It will restore the screen. Yes. Can also see the screen. Copy file from our computer to the touch panel. Take time also for this restore. Yes. Okay. You see the remind file of H. Yes. So it will copy 3 files more for finish the restore. So it's very easy when we have the ProCell program, yeah, for restore and backup the touch panel. So wait a moment. File of H, right? This file we cannot extract. Yes. If we extract the file, we lost everything, and otherwise we cannot restore also. Yes. So don't extract this file. Okay. Switch off H. So remaining 2 files more for restore. Seven of H. Yes. Remain 1 file more for restore. And you see this one. Yes, nearly finished. Okay, the last one, 8 of 8 file. During the restoration, yes, restoration and the backing up, don't do anything on the touch screen, like the off power or something, otherwise it will error the touch screen. Okay, so don't touch anything on the touch screen. Okay, it will automatically reboot again after this one finish. Okay. Download complete. The device will now perform additional installation step. Okay. So right now finish, and you see the touch panel is rebooting. Yes. Waiting for a reboot. Okay. Okay, rebooting, starting. It's similar to be the computer, this one. Yes, reboot finish and waiting start, automatically start. Okay, so in the screen has only this one push button. Yes. Okay, so that's all for instruction how to back up the project file of touch panel by using LAN cable that connect to touch panel MP277 10-inch and touch. Okay, so thank you very much for watching my video. If everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. Okay, so in this time I would like to say thank you very much again and see you next videos. Bye bye. I would like to show and share about how to use the schematic process to back up and restore the project from touch panel. Okay, actually we can use the process to back up and restore the project with another HMI that we want. Right now I will use MP277 10-inch by LAN cable. Okay, in the next video I would like to introduce and share about how to back up the project from this model also, but using MPI cable. Okay, so now we will use LAN cable first. Okay, so we have setting, then I will share during the backing up. Okay, so first let's go to install the process first. Okay, so first let's install the process. Right now I will use version 16. Okay, let's install first before we backing up and restore the project. This is a new version. Yes, so we can download and upload the project. Yes, backing up and restore to another type of HMI that we want. I will show step by step how to back up and restore to another HMI. Okay, actually we don't need WinCC place at all if we use this process to back up and restore the file. Yes, for WinCC flexible we can create a new project and then download to the HMI. Yes, by we can modify something, but for the file we cannot modify something, so we just back up and restore. Example, we have a problem with the old or existing HMI, so we can back up the project from the HMI and order the new HMI and then restore the project that we already back up to the new HMI that we order, so we can use properly. Okay, the original file will restore to the new HMI by using the process. Okay, so right now wait a moment for installation for this software, and then I will show step by step about how to setting and how to configure on HMI before we back up and restore. Okay, so it's very important if we use the HMI, and then it will have lifetime, right? So we need to back up the project file to keep, and then if the old old HMI is lifetime or something, so we can restore. Okay, so please follow me step by step about how to back up and restore the project to the HMI. Okay, so right now ProSale software is installing. Actually take time around 3 to 4 minutes for the installation, then we can use it. Okay, it has many model of HMI. I will show after the installation complete successfully. That we can back up and restore to the HMI, okay, by using this ProSale. Actually, this HMI we have many ways to back up and restore, and I will show step by step. Example, we can use USB flash to back up and restore. We can use the MPI cable to back up and restore, and we can use another devices to do it. Okay, so I will explain step by step about how to do it. Okay, right now it finished installation, then we need to restart the computer before we go to backup. So please finish to restart the computer. Okay, right now we can open the software process by go to start and then go to find the process, or we can search by using semantic process, yeah, and then click OK. Okay, we will got like this. So it just upgrade, yeah, or install new version 16.0.1, yes. So here we have many model of HMI that we can use, yes. Many model of HMI like this, yeah. So right now I will use the HMI to match with our model, right? So MP 27710 touch, yes. So let's go to check MP 277 touch. Okay, we can find this step. We must be careful, otherwise we cannot back up the project, yes. If we choose the incorrect HMI type, yes. Okay, MP 27710 right here. Okay, had here and here, but right now I use the MP 27710 type, right? No V2, so no need to choose V2, so we can choose only 10 touch. And the connection right now I will use LAN cable, right? So I will choose LAN cable, and we need to put the IP address of HMI here. So before go to put the IP address of HMI, let me show how to check the IP address of HMI first, okay? Okay, so first we can go to the control panel and go to transfer, yes. Then we can choose the Ethernet, go to advanced, and we can go here. Here is the IP address of the HMI. We can put another IP address that we want, yes. So right now 192.168.0.2. If we would like to change any number, example I will change to .10, okay. 192.168.0.10. I will enter and then click OK. OK again. Okay. And we can recheck again to make sure the IP address that we put is correct, okay. So 192.168.0.10. Then we can click OK and go to S7 transfer property, yeah. We can go to check again. So make sure we select the correct function, S7 Ethernet, because we use LAN cable, yes. So that's correct. So we can go to click close and go to transfer. Don't forget, click transfer. So the IP address that we put is 192.168.0.10, right, for IP address of HMI. So we must put the IP address of our computer also, okay? So maybe I already put for my computer. Okay, I already put the manual for IP4 to my PC. So if everyone not yet put the manual of IP address of PC, please go to put like this, okay? And don't forget go to control panel. Yes, go to control panel and go to the window firewall. Yes, must close or turn off window firewall here, otherwise we cannot communication between our PC to the PLC, okay? So let's go to command prompt and then ping 192.168.0.10. yes, like this. So make sure the communication between our PC to the HMI is okay like this. Then we can go to backup tab and then go to browse here. Example, I will put new folder. MP 277 PK backup LAN, yeah, backup by LAN cable. So MP 277, yes. Then click open, yes. And then we will choose the complete backup with license, right? We choose like this, it means that we back up all the data from the HMI to keep in the folder that we already created here. Yes, okay. Okay, so we can click backup. Yes, start backup to backup the project. Yes, and it will start backup the project. Yes, let me show the screen. Yes, it backing up, yes, the file. Like this. So after winning, it will reboot the screen. Yes, directly, automatically. Yes. So please be careful. If backup like this, don't turn off the power or touch any cable. Example, LAN cable. So don't touch it. Otherwise, it will disconnect it and it can error also. Okay. So don't touch anything. When it complete properly, then we will got the project file. Yes. Actually, it can back up around use time around 10 minutes. Yes, depend on the project file on the HMI is big or small. Okay, so waiting for it complete and successfully. Yes. Okay, right now the project file is already backed up. Yes, here. Okay, around 63.2 megabyte. Yes, then we can close it. So right now the backup file is complete successfully. So let me show the screen. So here is the previous screen that we already learned in the previous video. Yes. So I will go to restore the screen back. Yes. So before restore, I will go to WinCC Flexible to create the new project and then download another project to this screen first. Yeah. Example, I will go to this screen. Yes. And then I will restore back to make sure we can restore it properly. Okay, I will download this project to the HMI. This is the existing project also that we already learned in the previous video. So this model, let's see, the model of HMI is the same as the hardware. Yeah, so we can download also. So before download, we can go to off the power and then wait a moment and then we can turn on again. Yes. Waiting for turn on. Okay, it will reboot. And don't forget click transfer. Yes. And then go to download, right? Okay, go to download. Okay, I will change this one to .10, right? Click download. Yes, to confirm download. Okay, downloading. And then it will reboot the screen automatically after download, right? So here is the project. Yeah, another project. Yes. Okay. So we can restore also. If I close this one, yes, and I will restore this file back. Yes. So before transfer or restore, let me turn off the power again and then turn on again. Because we need to click the transfer, right, before we restore. Otherwise we cannot restore the project if we don't click the transfer button. Okay, don't forget click transfer. And then I will restore the file that we already backed up. So go to ProSave again. And then go to restore and browse the file that we keep. So we keep on desktop, right? Okay. We keep on desktop and then MP back, right? Here. And then click the file. And we can click start restore. Yes. Okay. And then we will got the restore file. Okay. So when it complete, and we will check again. The screen should be revived, right? Okay. Take time a bit, around 2 to 5 minutes for complete this step. So wait for a restore complete successfully. In this step, please be careful also. Don't touch any LAN cable or power supply. Otherwise, it can error. Yes. So file of 8, right? So it will have 3 steps more for restore. File of 8, right? Okay, so wait for restoring. After that, I will show the screen should be updated to be the same as the project that I already showed before, right? Because we store this file to the HMI. So 6 of 8. And in the next step, I will show how to back up and restore by using the MPI cable and USB cable for this model. Yes. And then we will learn about how to back up with another model of HMI by using the ProCell. Yes. So many many model of Siemens HMI that we can use this software to back up and restore. Yes. So 7 of 8. One more step, it will finish. So let's see the file is fast. Yes. Will it finish? After finish, it will reboot the screen automatically, and then we can check the screen. So 8 of 8, right? Okay, nearly finished. Writing to plus, right? Let's see here, don't reboot the device. It means that don't turn off or don't do something. So right now it already restored, so it will reboot the screen automatically, and then it will start up. reboot. Okay. Okay, it will start automatically, don't touch. Okay, so right now we will got the existing project that we already backed up before, right? Okay. So this is how to back up and restore the project by using the ProCell version 16. Yes. And I hope this video is useful for everyone to follow me. If you would like and to back up another model, yes, back up and restore another model that has in this software, so we can use this step for backup and restore. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon, and I would like to request all of you to like, share and subscribe my video also, to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again, and see you next videos. Bye bye. I would like to show and share about how to back up and restore the project of HMI MP27710 touch. Okay. In the previous video, we already learned about how to back up and restore the project of HMI MP27710 also, but I already used the ProCell for backup and restore and use the LAN cable. Okay. So today we will use backup and restore the project by using the USB plus. Here is the back view of HMI. So there are two ports of USB ports, and if we would like to use any port, it's up to you. These two ports, yes. Right now I will use this port by insert this USB to the HMI port, and then go to option to back up. Inside the screen have the function for backup and restore. Okay, so after that we will back up for done, and then we will got like this, got file like this, and we can restore the file the same as the picture. Okay, so the first step, let off power, yeah, turn off power the screen, yes, and then insert the insert the USB to the port of HMI, but the USB should be a format I will show in the next step, yeah, after this presentation. Okay, then we will got the option backup and restore here, and then we can click for backup. Okay, so let's go to our project. I will go to show with the how to format the USB plus, okay, to support with this backing up and restore. Okay, right now I will insert the USB plus. Okay, okay, here is my USB plus. So we need to format, right? Okay, right click and then format, and please choose like this, yeah, choose default. Actually choose default, click default, and then let's see here FAT 32 default. Yeah, so we can click start to format. Okay, format, yes, format complete successfully. Okay, and then let's reject the plus. Okay, this one. Okay, reject the flash and unplug from our PC. And then insert the USB plug to the USB port. There are two ports here and here. We can use another port that we want. Let me use this port first. So insert the USB plug to this port. Okay. Okay. And then turn on the power to the HMI. Wait a moment for boot the HMI. Take time a little bit for boot. Yes. So wait a moment for booting. Yes. Then go to control panel. Okay. We will find the function. Yes. Here. Backup / restore. Yeah. So we can double click. Okay. It will pop up like this. Yeah. So we can click backup. Yes. Okay. And we can choose another port that we want. Right now it detects one USB flash. Yeah. So we can start back up. Click start back up. Okay. It will back up the file from the HMI to store on the USB flash. Okay. So waiting for this backup. Actually, it takes time around 2 or 3 minutes for this backup. So wait for it will successful, complete and successful. During this backup, don't turn on don't turn off the power or touch anything for USB flash. Otherwise, it can be error. Okay, so let's see here. Backup successful, complete. Okay, yeah, press OK and remove your storage card. Okay, so we can press OK, and I will take out the storage card. Yes. Yes, can remove. Okay, and let me show the file. Yeah. So after remove, we can see the normal screen here. Okay. So let me show the file that we got from HMI. So let me insert USB to PC. Yes. Okay. Let's open the USB plus. Yes. We will got this file capacity around 5 megabyte. Yes. Okay. And inside here have like this. We can also open. Yes. If we have WinCC runtime, we can click to run the screen. Yes. WinCC runtime. Yes. We can click. Yeah. So the screen has only one screen. Yes. Like this. And I will download the another project to the HMI. Yes. And then restore this file to make sure that we can restore the file to the HMI. Okay. So I will insert and download another project to this file. Example, I will download this one. Yes. By using the LAN cable to the HMI. Okay. Here is the model number MP27710H. So I will download this project to the HMI. Right now I will connect LAN cable from HMI to the PC to download the project. Yes, insert the LAN cable. I will insert the LAN cable to my PC. So wait a moment for reboot the screen. Yes. And then we can ping (192.168.0.2). Let's check the manual IP address of my PC. Okay. Then let's check the HMI IP address. Okay, USB. Let's check the IP address of HMI again. So let's go cancel first, then go to control panel, go to transfer Ethernet .0.10, right? Okay, so IP address of HMI is .0.10. Okay, I will please transfer. So we can ping .0.10, right? Okay, we can ping. Then we can download. Change this one to .0.10. Click transfer. Click yes to confirm. Okay, then it will reboot the screen. So right now I already download the screen, like this. So we will restore the screen that we got from the backup to USB plug to the HMI, right? Here we will restore the screen here to the HMI. Yes. Okay, so I will reject the USB plus. Okay. And then turn off the power of HMI first before restore. And then insert the USB. Yes. Insert the USB plus. I will take out the LAN cable. Yes. Insert the USB plus to the HMI port. Yes. And then turn on the power again. Okay, wait a moment for boot. Actually, when we use USB plug to back up and restore, it faster than another use process or some connection. Yes, so it fast, very fast. Okay, and then click control panel. Yes, and go to the backup and restore again here. Yes, double click and then go to restore, and it detects one USB plug. If we not detect, we cannot download or restore. So we can press refresh to refresh the screen. Yeah, and then right now it found one USB plug. Yeah, then we can click start restore to restore the file to the HMI. So wait for restoring. Yeah, it asks to confirm. You are starting restore now. All file accept file on storage card, and the registry will be erased. Are you sure? Okay. So click yes to confirm. Okay, it will restore back from the USB plus to the HMI, and the screen will change the same as I open on the PC to show. So waiting for this restore. it faster than use LAN cable or MPI cable. So in the next video I will show how to back up and restore by using the MPI cable, but we need to connect to the PLC S7-300, okay, by Profibus cable, and then we can connect from Profibus cable to MPI cable and use the USB port connect to PC by using the ProCell software to back up and restore. Okay, so I will show how to do. There are many ways to back up and restore the project file. So it just how to know about the way of working, so we can do it. Okay. In this time also, please be careful. Don't touch any power. Don't turn off any power. Otherwise, it will error. Yes, error system. So don't touch anything. Wait it restore by itself successfully. Okay. Restore CE image because we use Windows CE, yes, for this HMI. So if we modify, we want to use the screen, we need to have WinCC flexible, right? For all these files, backup and restore, we cannot modify any screen. So it just backup and restore only. Okay, we cannot modify the screen, add the more screen, or modify some function inside the screen if we use this way. So if we would like to design or add one more screen, we need to use the original file to modify. Yes. Okay, right now restore finish. The device will reboot now. Don't remove the storage card. Okay. In this step, please be careful. Yeah. Don't remove the storage file or the USB plug. So just click OK, and the screen will reboot automatically. Don't touch anything for USB plug or turn off the power. It will reboot and restore. Yes, continue to restore by itself. Okay, rebooting the screen. Okay. It will continue to restore the file. Okay. So we can refresh. Okay. Now it restore. Continue to restore the file. Okay, restoring file. if compared to the LAN cable or MPI cable, the USB plus way is the best way, yeah, because we use short time to do it. So right now, let's see, restore successful, finish, please OK, remove your storage card and reboot your device. Okay, so let's please OK, and then I will remove the USB plus. Okay, remove USB plus has been removed. So waiting for reboot. In the next step, I will show and share about how to back up and restore another model of HMI for Siemens brand. Yes. Okay. And then it will start automatically by itself. Okay, so right now we will got the same as the screen that I already saw on the PC. So let me insert the USB plug to computer again, and then open. We close this one. Yes, and let open. It's so like this, it means that we not connect to the PLC, so it's so like this. Okay, let's open the USB plus. We will got this file, yes, and we can open back. Yeah, so the screen and the screen on HMI is the same, right? Let's see here. Yes. Okay. So we can restore, back up and restore the file successfully. Okay. So this is just example about how to back up and restore the file to the HMI MP27710H by using the USB plus. Yes. And I hope this video is useful for everyone. If everyone would like to back up and restore the file fast by using this way. Okay. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And in the next step, I will show and share to everyone about how to back up and restore with the HMI. Yes. And we can use another model of HMI to do for this way. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Try to show and share about how to create sample project from Semantic Step 7 Microwin version 4, the page 9, yes, and WinCC Flexible Smart version 3, then connect from PLC S7-200 CPU 224 HP, and also create the screen for HMI Smart 700 IE V3. Okay, and this is a front view of HMI, yes, and this is a back view of HMI that I already connected cable RS232 cable from this port to the PLC, and then I will connect the LAN cable or RJ45 cable from the computer to the HMI. This cable for download project of the HMI, yes. First we will create the project in the computer, and then we will download to the HMI by using WinCC Flexible Smart version 3 and LAN cable to download to the HMI. Okay, and for the PLC S7-200 CPU HP 224, yes, I will use the PPI cable, convert from the RF485 to the USB port, yes, and for the download the project of WinCC Flexible Smart version 3, I will manual my computer to 192.168.2.253, and for the HMI we will configure the IP address 192.168.2.3. okay, so let's go to our software to create the sample program and the new project of WinCC to test. Okay, so let's go. So right now I will use this software first for Step 7 Microwin version 4, service page 9, and WinCC Flexible Smart version 3. Okay, so open the Step 7 Microwin, yes, and first check communication. So I will connect the USB cable for connect from the PLC to my computer, yes, yes, and then we will create sample project, yes, for start and stop one motor or one output, yes, for test only, because it is the instruction. If we can connect from the HMI to the PLC, it means that we can do everything. Okay, so it's just sample project. So first we can command, yes, write the command example start and stop one output, yes. So first we will create the symbol, right? Example stop address M0.0 stop motor 1, stop button, yeah, stop PB, yes, stop push button, and this is the start PB. It means that start push button, yes. Address 0.M0.1, yes, and command start motor 1. And for the status of motor, example motor 1 status, and I will choose Q 0.1, sorry, Q 0.0, and this is the motor 1 status. Okay, so we can compile and go to the program block, yes, and then I will choose NC, yeah, nominal close, and this M0.0, yes, for push button stop, and this is a start, right? So M0.1, yes, push button start, and one more for output, Q0.0, yes, for motor number 1, and then I will hold signal, yes, from Q0.0, yes. Okay, so save our project, yes, to desktop, and then we can write connect to HMI smart .200 IE, yes, and then we will go to the HMI for create the push button start and stop and the status of motor, right? So let's go. First, open the WinCC Flexible Smart version 3, yes. And go to this button, yes, click, and choose the correct HMI device, yes. Right now we use Smart to 700 IE V3, yes. This is, we need to compare the nameplate of the HMI, otherwise we cannot download the project, yes. Example, the hardware, yeah, is Smart 700 IE, and then we choose the Smart 700 IE V3, we cannot download to the HMI. Okay, so this one is very important, so we need to choose the correct model of HMI, yes, and this is the version, yeah, version 3 or something. Actually we can use this one or use this one, yes, it doesn't matter for this one, but the most important is select the model of HMI to be matched with the hardware. Okay, so I will select 700 IEV3, yes, to match with my HMI, yes, and then click here and wait a moment. Yes, wait a moment. Yes, right now the screen is appear, yes. So first go to this button, yes, this button, and then double click here to create a new connection, yes. Example, Smart 200 IE, yes, 700 IE, sorry. And this is a driver that we would like to connect to, yes. Right now we will connect to schematic S7-200, yes. And this is the default, yes. So we need to no need to change everything. So this is the port that we will use. Normally this HMI we can use the IP address. It means that Ethernet, yes, Ethernet communication. For other PLC, yes, example the PLC S7-200 Smart or PLC S7-300 that have the Ethernet port, we can choose this one. But right now we use PLC S7-200 CPU 224 HP, so it doesn't have the Ethernet port, so we will choose the IF1B port, yes. And normally we use the PPI cable, yes. So select PPI cable and then select here, yes, 9600 for baud rate, yes. Okay, this is very important. If we choose the not correct function, we can not control from the HMI to the PLC. Okay, so this is a PLC station, yes, address number 2 and PPI address 31, yes. So we will choose like this. Okay, save the project first. I will save to desktop, yes, and create the new folder. Example, connect to S7-200 CPU 224 HP, yes, like this. And this is a project name, yes. So I can write Smart 700 IE, yes, like this. So after we save, it will create the new folder for us, yes. So the next step, we can close this one, yes, and go to the text, right? So double click here, sorry, double click here for create the text, right? So for our text has 3 texts, right? Start, stop, and the motor status. Okay. So double click here and then example stop PB, yes. And we will choose the boolean and start from %, right? 0.0 for stop. And this is the start PB, right? M0.1, yes, correct. And the last one for motor 1, yes. Boolean also, but we will use Q0.0, right? Okay. So right now we already created the text, yes. So let's go to our screen and then create the button, yes. Go to button. Yes. Example, this button is stop, yeah. And then we will change the color. Go to here, yeah, and change the color. Example, red color for stop button, yes. We will resize, yeah, the button stop. Yes. Font, yeah, we can change the font also, yeah. Example, to bigger than here. Go this tab and then 28, yes. And then I will copy this one for start, yeah. Control C, yeah. Control V, yes. For start. This one is start button. Align to be center, yes. And I will choose the green color, yeah, for start. And the next step, we have the one motor, right? So example, this is a motor, yeah. But actually we can choose the motor from this library also, yeah. Yes, let's find the motor. This is a pump, right? Sample fan, yes. Example, the motor fan, yes. Like this. And this is a stator, yeah. We can write like this, yeah. And drag to here. Example, color this like this. Yes. We can adjust. Actually, we can adjust, yeah. Okay, like this. It has many symbols in this block, yes. If we would like to use other symbols, we can use from this block, yes. So right now I will configure the button start and stop and the motor setter, yes, to be can start and stop from the HMI, yes. Okay, so first go to button stop and then go to this tab, yes. Yes, this tab, and select set, yeah, set bit. So set bit stop, yeah, stop PB, right? And when release, will reset bit, right? Reset bit stop PB, right? Okay. So when we press the button, the motor will turn on, and then will when we release, the motor still on because it holds signal from this contact, right? Okay. So next, for this button, yes, go to this tab and then set bit also. Set bit start PB, right? And when release, yeah, reset bit start PB. Yes. Okay. And for the status of motor, yes, we can go to here and then here, right? This one is a take, yeah. So motor, we can write motor and choose the motor one. And this one, yeah, this one is bit. So we double click, and this is a 0. For 0, example 0 is a red color and 1 is green color. Yes, like this. Yes. So save our project, and then we will go to the HMI for setting the IP address and some parameter before we can download. Okay, so let's go to see the HMI. So first I will reboot the HMI, yes, and then go to control panel, yes, and click transfer, yes, and go to advanced, yes, and make sure you insert the IP address and subnet mark, yes, like this, or some other IP address that we want to set, yes, and then go to OK after you set, yes, and OK again, and close. Yes, close. And go to transfer, yes, don't forget click transfer, otherwise we cannot download from the computer to here, yes. Okay, so right now we already write the IP address or insert the IP address to the HMI, yes, and we will manual IP our computer also before we can download. So go here, right click and open network and internet setting, go to internet, yeah, change adapter option, and this one is the Ethernet adapter, right? So double click and go to IP4, yes, this one, and choose property. Normally when we not yet put the manual IP address, it will show like this, yeah, show like this. So we must make the manual IP address to be matched with the HMI, right? So 192.168.2. something, but not the same as the IP address of HMI. Example .4, yeah, because HMI .3, right? So this is a MAC address 255.255.255.0, and then click OK and OK again, yeah. And we can go to Windows R and then write CMD, yes, and then ping from our computer to the HMI, yes, 192.168.0, sorry, 2.3, right? Okay, it shows like this. It means that we can connect it, the communication between our computer to the HMI. Okay, so we can download. So to download the project to the HMI, let's go to this button and then choose this one and write the IP address of the HMI, right? So the IP address of the HMI 192.168.2.3, right? And then no need to tick this one, yeah, and this one, and then click this button. Yes, the file is transferring. Finish. Yes, you will see the file. Yeah, the project that we create in the computer, it transfer to the HMI already. Okay. So let's go to our step 7 microwin. Yes, this one. Yeah, and I will change the language because PLC is CN. CN, it means that China. Yes, so I will go to save again. Yeah, and then go to tool option. Yeah, general, and go to the Chinese. Okay, okay, and then save the project. Yes, and then this is our project, right? This one for HMI and this one for PLC. So open and go to and then we will download. Yes, okay, start the PLC. So before we online, I will go to the English first. Yeah, tool option. Yeah, go here and no need to save. Yeah, and then open again. It will come back to English version. Yeah, and we can online it, right? Okay, so right now we will test the touch screen. Yeah, so I will press the start button. Yes, you see the output is turned on, and stop button. Yes, turn off, start again. Yes, turn on, stop again, turn off. Yes, so it means that we can communication between our HMI and PLC. Okay, so this is an instruction and just example for everyone. So thank you very much for watching my video about how to communication and test the new project that connected from the PLC S7-200 CPU 224 HP CN, and then with the HMI Smart 700 IE version 3. Yes, so if everyone have any question, please drop comment under my video. I will reply soon. Yes, And I would like to request all of you to like, share and subscribe my video also to get more new notification and more new videos that I will create step by step. Okay, so in this time I would like to say thank you very much again and see you next videos. Bye bye. Try to show and share about how to simulation between Semantic Manager version 5.6 with WinCC Flexible 2008 version page 5. Okay, and here is the WinCC Flexible 2008, and here is the Semantic Manager that I already installed both of them in my PC. Okay, and I will connect the PC adapter from my computer to the CPU of S7-300. Okay, actually we can simulation if we don't have the touch screen. We can simulation from this one that we call WinCC Flexible 2008 to control the program in the hardware. Okay, so let's go to our software. Yes, okay, so here is the previous project of Semantic Manager that we already learned in the previous video. Yes, so I no need to create the new project of Semantic, but just create the new project of WinCC. Okay, so here is the WinCC Flexible. Yes, so let's create the new project for simulation. So right click, open the software, or we can double click to open the WinCC Flexible software, and let's create the empty project. Yes, and here is the laptop touch screen that we can use. Yes, panel. Yes, many panel. Yes, that we can use it. For me right now I will choose the touch panel. Yes, this one TP 7B 6-inch color PN/DP. Okay, so I will choose it. And first go to the connection. Yes, communication, and then choose connection. Right click and then open editor. Yes, and here is the connection name. Example connection name PLC, like this, PLC S7-300. Okay, like this. And online tab, in here we can choose another device, but right now I will choose the S7-300 and 400 because I use it. Okay, and here make sure you choose the online. Yes, and here is very important for choose. Example, I choose Ethernet. Yes, and I choose the IF1B. Yes, because in this device HMI it also have the internet also. Okay, so right now I will choose IF1B. Yes, and here I will choose the MPI because I choose the MPI adapter USB for connect from my computer to the PLC. Okay, and this is a PLC station, and here is the address of the PLC, and here is the baud rate. Yes, normally I choose this one. Yes, so everyone can follow. Yes, by set like this. Okay, let's go to next. So the next, go to text and then open editor. Yes, we need to create the text for start and stop the output. Yes, example, this is a stop button and this is the start button, and here is the some status of the output. Yes, so let's create the text. Okay, go to tab text. Here we can close it. Yes, go to tab text and then click here. Example, stop, and I will choose the boolean because we use the boolean on and off. Okay, and then we click we will choose M and M0.0. Yes, this is the M0 and this is the bit number 0. Okay, and one more for start. Yes, this button, and this is a M0.1. Yes, and next create some status of the output, right? Example, Q 4.0. Yes, I will choose a Q. Yes, and for bit number 0. Yes, one more, Q.1 4.1, right? And it will automatically generate for us Q 4.2. Yes, this one, Q 4.3, and the next Q 4.7, and we will change this one also, change to bit number 7, and the last one Q 5.7. Yes, like this. Okay, right now we already create the text, and then let's go to create the button. Yes, some button for control the output. Example, I will choose the one button. Yes, in the text I will choose the stop. Yes, and I will choose some color. Go to property and then choose the red color. Yes, and I will copy this one and then change to start, and then I will change the color to green. Yes, because normally we use the green for start and red for stop. Okay, so configure the button. Let's go just click here and then go to the event, and if we freeze, we would like to set the bit, right? So set bit and bit stop, right? Okay, so bit stop. When press, set the bit stop and release, also reset, right? Reset the bit stop also. Yes. Another one for start, press, set the bit start also, right? Okay. And when release, reset the bit, right? Start also. Okay. So we can save our project and then go to the desktop and go here in the previous video, example HMI, and we can simulation for test. Yes. Okay. Right now I will click start. Okay. And the PLC is on also. Let me show you. Yes, right now the output is on also. You see. If I press stop, okay, start again. Yes. Stop again. Yes. Okay, so let's continue to create the state of output. Okay, so let's go to here, cycle, right? Some cycle. Okay, I will adjust to be smaller than this. Okay, like this, and choose the text for the some text. Example Q 4.0. Okay, like this. Adjust to be good looking. Okay, I will change this color to red. Yes, and also this one to red also. Okay, so let's change the status. When this one on, it will show the green color, right? So go to property and then go to color animation, go to text Q 4.0, right? And then choose the bit. Yes, because we use the bit boolean. Yes, and double click here. When it's 0, it will show red, and double click here. When it's 1, we can change the color. Yes, flashing no need. Yes, or we can use the flashing also. Okay, but in this section I not show the flashing. It means that it blink blink blink. Yes. Okay, so this one we can copy. Yes, click and then press Ctrl and Shift to copy. Yes, like this. Totally 5, right? Okay, 6. 1, 2, 3, 4, 5, 6. Okay, 6. So we can align it to be center. So this one Q.1, right? Just change like this and change the text also. And this one is the Q.5, 4.2, right? This one Q4.3, right? This one Q4.7, Q4.7. General, change the text to Q4.7, and this one Q5.7, right? And we change the general Q5.7 also. Okay. So let's save our project and then simulation again. Okay. Let me start. Yes. You see the color is changed because we already config the status animation. Yes. If I stop, and the PLC also on the output. Yes. Okay. Like this. So thank you very much for watching my video. If everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like and share and subscribe my channel also to get more notification and more new videos that I will create for show and share to everyone. Okay. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Today I would like to show and share about how to connect the HMI LS brand to the PLC S7-300 CPU 3.4C 2PN/DP. Okay. And in this section I will use two softwares. The first one is Schematic Manager version 5.6 for configuration the S7-300 software. And the second one I will use LS software HP Builder version 2 to configure the screen for test and connect with the PLC S7-300. Okay. So I will use LAN cable for connect from my PC to the LAN port of CPU of PLC S7-300, and then connect one more LAN port to the HMI. Okay. And here is the IP address of HMI, and here is the IP address of PLC, and we need to put the IP address of our computer. Okay. So this is the IP address is the same range, so we can ping from our PC to the PLC, and also can ping from PLC to the HMI. Okay. So we can control start and stop the lamp 1 to lamp 4 by using this button by config on the PLC S7-300 software. Okay. So let's go to our software to make the configuration and testing. Yes. So first I would like to use the schematic manager to create the hardware configuration. Okay, so I will create a new project. Example HMI LS. Let's go to File and then click New, and then browse to find the folder that we already created on desktop. So HMI LS, and this one I can type HMI LS and then click OK. So first we need to insert object of PLC S7-300, example LS HMI, and then we can go to hardware. So wait a moment for open the hardware configuration, and then go to schematic 300 and then go to rack, add the rail to the project. Okay, and then go to add the power supply. So go to PS, example I use this one, so drag and drop. Actually we need to put the same as the hardware, yes, but actually I don't use it, so I just put here and go to the CPU 300. Right now we will use the CPU 314C 2PN/DP, this CPU, so drag and drop. So here is the IP address of the PLC S7-300. Yes. And I have one more card for analog input module. SM311. Yes. AIH 12-bit. Okay. So let me insert it. So let's go to SM300, right? And I will add the analog input. Yes. And this one, yes, the part number 7KF02. So drag and drop to the rail. And I need to configure the position, right, of the analog input card. So the first one is PT100. So I will select PT100. The second channel is PT100 also. And channel number 4 until channel number 7, I will use 2Y of current. Sorry, 4Y of current, 4 to 20 milliamp. Yes. And here is the address. Yes. And here is the address of onboard CPU. So if we would like to use the digital input, it will start from I136.0. Yes, and for analog input, it will start from 800. Yes, PIW 800. So let's go to download. Before download, we will set the manual IP address of computer, right? So if now I ping 192.168.0.2 cannot ping, right? Or .0.1 we cannot ping also, because we not yet put the manual of IP address of computer. Okay, so let's go to put manual, go to property and go to IP4, and we will put 192.168.0.253 example, and subnet mask 255.255.255.0. So now we can ping again. Okay, so like this, it means that we can ping to the PLC, and one more for HMI. We can ping also for 192.168.0.2. Okay, so we can download the project for hardware configuration. Okay, let set temporary part. Yes, go to option and then set PC interface, and then go to the PC adapter, right? Right now we use LAN cable. Let's check the hardware here. Which cable that we use here? Intel Pro 1000 MT, right? Active here. Yeah, this one. Yes. And then we can download again. Yes. It detects one CPU 192.168.0.1, and then we can download the hardware configuration. And start again. So right now we already create the hardware configuration. So we need to create the program for start and stop to control the lamp 1 until lamp 4, right? So let's go to OB1 and then choose the another language that we want. For me, I will use ladder. So here is the lamp 1, so we can comment. So I will write stop for lamp 1, start for lamp 1, and lamp 1 output, and I will hold the signal. Okay, so we can use the M 0.0, and you can comment. Example, PB stop lamp 1. Okay, and here is the address, example M 0.1. Then we can edit the symbol. PB start LAMP2, and here is the output. So if we would like to control the lamp, let's go to see the hardware configuration again. Here is the digital output. So it will start from Q136.0. Yes. So Q136.0. And then we can edit the symbol. Example, lamp1 status. Okay. And this one should be hold the signal, right? So lamp1 status also. And then I will insert one more network for lamp2, lamp3, and lamp4. So insert one more network, and I can copy the command here. And we can use NC, NO, coil, and hold the signal. Yes. And here we can use M 0.2, right? Because here we already use the M 0.1 and M 0.0. So it should be PB stop LAMP2, and this one should be M 0.3. So PB start LAMP2. Okay, and this one should be Q136.1. LAMP2 status. Yes, and this one should be LAMP2 status also. And I will insert one more network for LAMP3. So use the same instruction. Sorry. Okay, this one should be M 0.3. PB stop lamp 3. M 0.4, M 0.5, right? So PB start lamp 4. Sorry, lamp 3. And this one should be a Q136.2, right? And we can edit. Lamp 3 status. Okay. And this one should be lamp 3 status also. And the last one for lamp 4. So an O and C coil and hold the signal, right? So this one should be M0.6. PB stop, PB stop, lamp 4, M0.7, PB start, lamp 4, and this one should be Q136.3, right? And we can edit symbol, lamp 4 stator, and this one we can copy, yes, and then we can save the project and download the logic to the PLC, and we can online. Okay, so we need to create the project of HP30 control from the LS HMI, right? So let's go. First, let's go to open the HP Builder version 2 and create a new project and choose the series of the HMI. For me right now I will use HP series and choose the HP S7-300 TTA, yeah, to match with the hardware of model of HMI. And here is the controller. It should be select the correct controller. So on marker I will use Siemens AG because right now we use the Siemens. Actually we can connect to another brand that we want. Example, Yokogawa, Omron Corporation, Mitsubishi, LS, IS, and another brands that we want. Okay, so right now I will use Siemens AG and choose the protocol, product S7 400 Ethernet because right now I use LAN cable, and go to the communication setting, and we will choose the communication to correct the function. So detail here is the IP address of PLC, yes, so 192.168.0.1. here is the IP address of PLC here. So click OK and then OK again. So we will got screen like this. So first I can go to the screen property and change the color background to be this color, yes, and we need to create the button, yeah, for start the lamp one, right? So go to bit switch. So we need to create the stop button, right? Example, this is a device address, so it will start from M0.0, right, for stop button of lamp 1. So here we can choose M0.0, yes, here M0.0. So we need to choose M0.0 and then click OK. And I will use the momentary because when freeze it will on, release it will off. Okay, so I will choose momentary. And if the display like this, we are difficult to see, right? So we need to change the button background. So we can go here and then go to a library. We have many library that we can use. Example, we can use this button. Yes. And then we can change the color, right? Can change the color. For stop button, I will use red color like this. Okay. And we can copy. Yes. For start button. So copy and then paste. Okay, we can align. So here we can go to property, or we can double click. Yes. And here is the button start, right? So we need to put the address with correct address. So M0.1. Here we can type M0.1 and momentary also, right? And for the display, I will change this color, or we can use the blue color here. Okay. So we finish the lamp one, so we can put the text. Okay, example start. And this one should be stop. For lamp 1, right? And then we can copy to another lamp 2. Sorry. This is for lamp 2 and this is for lamp 3. Actually, we can adjust to be smaller than this. Let me adjust a little bit. Okay, like this. Or we can copy to be the same, right? Okay. Please Control and Shift and then drag and drop. Can also copy. This one M0.1, right? And the display should be blue color. Adjust to be aligned with the button. Okay, like this. And then we can drag and drop for copy. Not enough, right? So we can align a little bit. Okay, for lamp 2. This is just example. Actually, we can design to be good looking. Yes. So we can align. Okay. Okay, test like this, and then we need to change the address, right? This one should be 0.2, M0.3, M0.4, M0.5, M0.6, and M0.7. Okay, and this one for lamp 1, so we can mark. This is for lamp 1, this is for lamp 2, this is for lamp 3, and this is for lamp 4. So I will change this one to lamp 2, this one for lamp 3, this one for lamp 4. Okay, and we need to create the lamp stator, right? So let's go to bit lamp. Okay, like this, and we need to put the address, right? So it will start from Q 136.0. So let's go to Q 136.0. Okay, and for display we can choose here. The stator on, it should be green, right? So I will choose green, and when off it will show red, right? So when it off, it will show the red color, right? And it on, it will show the green color. Yes, so we can drag and drop to here. Okay, and we can copy this one. We can use the lamp one here. Lamp 1 status, right? We can adjust the size a little bit. Okay. Then we can copy, yes, for lamp 2, lamp 3, and lamp 4. Yes, and change this one to lamp 2. Lamp 3, lamp 4, and we need to change the address, right? For the lamp 2, it should be Q316.1. Yes, so 316.1, 316.2, 316.4, and we can adjust like this, and we can copy the text to add the title. Example, connect LS HMI HP30 to PLC S7-300. Okay. CPU 314C 2PN/DP. Okay, and we will adjust the font size a little bit. .11. Okay, good. I will change to be this color. The red color, right? Okay. So we can download the project of HP Builder to the HMI, right? Because right now we already connect it, yeah, from our PC to the PLC, yes, sorry, to the HMI. So we can download this project, yes. To download this project, we can click download, and we can choose the setting, yeah. Right now we use the Ethernet module, right? Ethernet port. So we can click the Ethernet and make sure that we put the IP address, yeah, correct the IP address, and then choose the correct hardware adapter, yes, here of computer, and we can scan the HGT panel, yeah. Here is the IP address of HMI, yes, and then we can click OK again, and we can click download, and project will be download, yes. So we need to save the screen, right? So let's go to desktop and then go to the HMI LS project, right? We can put project 1, and then click save, and it will download the project to the HMI. Let's see right now downloading the project. Okay, finish, and the screen will start up. successfully for downloading. So let's go to logic, our logic, and we can freeze to see the status. So if I push the button start, yes, let's see, the lamp 1 is turned on, and the PLC is turned on also, yes, the status. So I will connect power to the output of PLC. Okay, so right now I already connected the cable power to the module of PLC S7-300. So let's test again. Okay, right now let's see, the output is turned on. Yes. So if I push button start for lamp number 2, it on also. Number 3 on also. Number 4 on also. Okay. So we can stop. Example, I stop lamp number 3. Yes. Number 2. Number 4. And number 1. Yes. Start again. Yes. So we can start and stop and show the condition of PLC. Yes. So if you would like to control, we can connect the cable from output to control the relay or some electrical devices. So we can control, yes, from the HMI. Okay. So this is just instruction about how to connect the HMI LS brand to PLC S7-300 CPU 314C to PN/DP via LAN cable. Okay. So thank you very much for watching my video. If everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Today I would like to show and share about how to use Schematic Manager and WinCC Flexible to configure the analog input module. The first one is analog input module 331 F02 0AB0. It is the analog input that we can select use for PT100 or thermocouple or current 2Y, 4Y, and also volt DC for input. And here is the analog input, also model 7P F01 0AB0. It is the analog input for only PT100 type. Yes. So there are 8 channels in this module for PT100. So we can connect directly of PT100 to this module and it will show. Yes. And for this selection, I will detail for how to connect the PT100 or thermocouple 2Y that convert from the thermocouple signal, and then 2Y connect with this module. Okay, so I will detail all for this section, and we will connect with the HMI also, yes, to show the actual value of PT100 and TC on the HMI. Okay, so first let me explain a little bit about how to select send for this module, because right now I will use input type for all selection from A, B, C and D selection. Okay, so let me explain the hardware. So for channel number 0 and number 1, I will select to A. Yes, A, it means that we can use the 800, 250, 500 and 1000 millivolt. Yes, or PT100 or TC for this channel. Okay, when we selection to A. And for B, we can use 2.5 volt, 5 volt, 1 to 5 volt or 10 volt DC. Okay, so I will select to B for channel number 2 and number 3. And for channel number 4 and number 5, I will select to C, and then we can use the 4 wise current, yeah, 4 to 20 milliamp 4 wise. And for the channel number 6 and number 7, I will select with D. D, it means that 2 wise, the same as my slide that I already show. Here is the 2Y transmitter. So I connect the thermocouple plus and minus to here, and then when we select 2Y selection of the hardware, it will generate 24 voltage for us. Okay, here is the 24 voltage plus, and here is the 24 voltage minus. Okay, so we will got the supply to the temperature transmitter for 24 voltage. Okay, from this terminal. Then if the thermocouple generate the got the hotter or heater, it will connect to here, and then transmitter will generate 4 to 20 milliamp to the analog module. Okay, so this is just summary about how to select. Yes, I will select with 2 options, sorry, 4 options, A, B, C and D. Okay, so that's all for this module. We can select 4 options. Okay, and let's go to how to wiring for module for PT100 and this module also. I will summarize only one page for easy to understand. Okay, so let's go to check together. Okay, here is the detailed drawing of these 2 modules of analog input. The first one is analog input that we select with the 2Y transmitter here. So I will use terminal number 16 series with the milliamp meter 4 to 20 milliamp. Yes, connect with the terminal number 16 and number 17. I will connect directly to the temperature transmitter 2Y, because when we select to the 2Y option for hardware, it will generate 24 voltage here, yes, to supply the transmitter. And then I will use the TC connect from the sensor to be this terminal, yes, of transmitter. And then for the PT100 we connect like this, yes, and this is a connection for 0 to 10 volt DC, and here is the current for 4Y. Sorry, this is a 4Y, not 2Y. This is a 2Y connection. Okay, I will correct this one. This one should be 4Y. I'm also sorry, this confused. And here is the module of PT100 8 channels, yes. So we can use for connection 24 voltage for supply, number 21st terminal, and then 40 for minus, and 21st terminal with the plus. Okay, and here is the connection or channel of PT100. The first one, we can jump connection terminal number 3 and number 5, number 4 and number 6, and then the sensor will connect to the number 3 and number 4. Okay, so we can connect like this for all channel of PT100. Okay, and for the address, it will generate when I show on the software Schematic Manager. Okay, so this is a summary of these two modules, and please this is a 4Y, yeah, not 2Y. Okay, so let's go to see the Schematic Manager to config. Yes. Okay, so first I will create a new folder for PT100 or TC testing. Okay, and then I will use Schematic Manager and WinCC Flexible to create the new project and simulation the touch panel. And the next video I will download to the actual panel. Okay, so first let's open Schematic Manager. Okay, and then I will create a new project. The project name is TC PT100. Yes, browse to find the folder that we already created on desktop here, and then click OK. So first we need to create the new station of Schematic S7-300, example TC PT100. Okay, then let's go to click to hardware configuration, and then we can insert the rack, yes, for this project. We decide to be like this, and then go to SM, yeah, go to insert the CPU. So right now I will use CPU 314C2PN/DP, the same as the existing video, and here is the IP address. And then let's go to add the two more module of analog. The first one is the analog this module, yes, here 7K F02, right? So let's go to SM300. AI and then go to scroll to find the module that made with our hardware. Yes, 7K F02, drag and drop to the rack. Okay, and then we need to selection to be the same as the hardware configuration, right? Okay, let me show the same as here. Yes, here we need to follow up with here. The first one is A, so PT100 or TC, right? Okay, so we can go to double click and then go to the input type. So we can select RTD, and normally I use the PT100 standard. Yeah. And for channel number 2, we select to B, right? So B is 0 to 10 volt. It is correct. Yes. So no need to select. And for channel number 4 and number 5, I will use 2C, right? Select 2C. This one. C means that 4Y current. Yes. So for Y current, I will select to 4DMU, yeah, for Y current, and start from 4 to 20 milliamp. And for channel number 6 and number 7, I will use 2Y. So I will select 2DMU, 2Y here, current 2Y, and then 4 to 20 milliamp also, okay. So that's all for configuration. We must follow up the selection to be the same hardware that I already explained here. Otherwise, when we download the software configuration to the hardware configuration, it will show SF. It means that fault, system fault, yeah. So we make sure to select the software to be the same as the hardware, okay. Otherwise, we cannot download, or it will got SF, okay, system fault. So that okay, and then we will add one more module for PT100 module A channel, right? 7PF01, okay. So let me check 7P, right? 7P PT100 here, 0, it is 01, yeah, it is correct. Yes, and here we need to selection also, but we have only software selection. For hardware we don't have. Yes, so for input we can select here the PT100 type. Actually I always use 3Y. Yes, and the PT100 type is standard. Yes, here. And for other channel, we can selection the same as this channel. Yes. Okay, standard. Okay. And then we can click OK. And then save the project, compile, and then download, right? So before download, we need to connect the LAN cable from our PC to the Profinet port of PLC, right? And don't forget put the manual of our computer. Yes, like this, example 253. Yes, put like this and then click OK. So we can ping to test so CMD and then ping 192.168.0.1, right, for our CPU of PLC. So it's so like this, it means that we can communication between our PC to the PLC, right? So we can download. Okay. Run the CPU. Yeah. So right now I will show we don't got the SF. It means that no system fault here. It means that hardware configuration and software configuration is correct. Okay. So let's see here. We don't got the SF fault. Yeah. So it means that hardware configuration that we select and software configuration that we download correct and can use properly. Okay. So then the next step we will create the logic or scale to show, right? Okay. So let's go to our block. Open OB1 and then I will use ladder. Okay. So first I will use the PT100 to show, right, for this channel. So start from PIW 256. Okay. So for this channel we can also online here to check. Follow our address. So PIW 256. Yes. And we can online monitor. Right now the temperature show around 26.3, right? Okay. So we can get the. So first we need to convert from double integer to double integer, right? We use this one. And then convert to real, right? So di to real, double integer to real, and then divide real, right? Divide by 10.0, right? The same as the previous video for PT100 channel 1 or sensor 1. Okay. Then here is the starting address. Yeah, here PIW 256. Yeah, PIW 256 here. Okay. So we will put PIW 256 and then we can command edit symbol with PT100 or sensor 1. Okay. And here we need to create the temporary variables, right? Let's go to temp and I will use the temporary, yeah, example temp1. It is the double integer, right? So dint. So temp1 here, and we can copy and then paste here. And we need to create one more for real data type, right? Okay. So temp2. It is the real, right? So real. Then we can put temp2, copy and then paste here, and we will show on the HMI, right? So we can use MD 0. Okay. and then we can save and then download to the CPU, and then we can online. Okay, so we will got around 25.6 degrees Celsius, right, for sensor number 1. Okay, so we need to create one more channel, yeah, for 4Y, right, 4Y transmitter, or we can use the standard soft loop control or loop testing to use, right? So here we can use the insert the network, example channel number 4, right, this one. Channel number 3. Yeah, channel number 3, we need to use the example sensor sensor 2 signal 4 to 20 milliamp. Then we can use the FC105, right, that I already explained and tested in the previous video. So we need to convert, right? FC, right? FC105 here. Okay. Then here is the input, right? So input channel number let's go to our drawing. Yes, this input for channel number 3, right? It is the 4Y. Yes. So for Y we can use the address. So PIW 256, PIW 260, 262, and this is 264, right? 264. So PIW 264. Yes, 264. Right now 20 milliamp. Yeah. I decrease to 4 milliamp. Okay. And then we will got like this. So we can use PIW 264, right? For channel number 3. PIW 264. And then we can use the converter. It is the symbol. Yes. Sensor 2 signal 4 to 20 milliamp 4Y. Okay, like this. So we can change the symbol to be an integer. Yes. Example sensor 2 signal 4 to 20 milliamp. Yes. And here is the high scale and here is the low scale. Example, I use 100 for high scale, and here is 0 to 0 for low scale. And for the bipolar we can use address, example M100.0. okay, and here is the value, example MW 20, and here is the output, right? So example MD 4. Yes, so we will got the signal like this, and then we can download. Okay, so right now around 0 degrees Celsius. If I adjust, I will test to 20 milliamp, it will show around 100 degrees Celsius. Okay, let me decrease to 4 milliamp. Okay, we will got 0.05 degrees Celsius. Okay, so that's all for module number 2, and then we will use the module number 3, right, for this one. Okay, for 2 wires selection. So this is a thermocouple, so we can use the same as this one. So let's create for sensor number 3. Sensor number 3 connect with temperature transmitter 2Y. Yes, this one 4Y, and this one 2Ys. So we can use the converter from integer to double integer. Yeah, this one, and then convert from double integer to real, right? So di to real, and then divide by 10 also, right? Divide real. Okay, divide by 10.0, and here is the address. For address, we will start from PIW 266, right? Sorry, 260. This is the last one, right? 264, 66, and 68. Okay, so right now the temperature so around around 6.6 milliamp. So this one we cannot do this function. We can use also the same, sorry, because we use 2 for 220 milliamp also, right? So we will use the FC105 to convert this one. Okay, so this one should be PIW 268. Yes, 268, and the data type should be integer also. So integer command sensor 3 for Y, start from 4 to 20 milliamp or so, right? Okay. And this is a rank example. I use 0 to 100 degrees Celsius also. 0 to dot 0 M 100.1 MW 30 MD 8, right? Okay, then we can save and then download. Okay, so right now around 16 degrees Celsius, but the scaling around 150. Yes, let me change the scale. This scale we put the same as the temperature transmitter that's set on the setting of transmitter, right? To be the same, otherwise it should not the same with the actual temperature. Okay, so in this scale we need to put the same as the scale that we setting on the temperature transmitter twice. Okay, so for module number 1, yes, module number 1 here we already created. So for module number 2, I just connect only channel number 1, yeah, of PT100. So let's create, go offline, and then insert one more network for signal from module 2 of PT100 sensor channel number 1. Okay, so for PT100 we can use the same as this one, yeah. So convert from integer to double integer, convert from double integer to real, and divide by 10. Yes, divide real. And then for the address we can check on hardware configuration, start from PIW 272, right? So PIW 272. Okay, right now around 25 degrees Celsius, yeah. Okay, so this one should be divided by 10.0, and this one should be the address PIW 272. Okay, PIW 272. Okay, and this one we need to create the temp, right? Okay, example temp 3. The data type is double integer, so temp 3 also, yes, and one more for real, so temp 4, it is the real, right? So this one temp 4, and I will use the MD12. Yes, so we can save the project and then download to the CPU. Okay, we will got the actual temperature around 25.4 degrees Celsius. Okay, So for part 1 I would like to explain about like this first, and for part 2 I will convert this one to show on the HMI, and then we can download the real project to the real HMI to show the value. Okay, so I would like to summarize for this section. So first we need to selection to be the hardware of the module, yeah, especially for module number 1, yeah, here we need to selection the hardware to be the same as the software that we already config, yes, here. Otherwise if we download to the module it will show system fault if we select the incorrect function here. Okay, so it's very important. And for the option that we use to convert, we have two options. The first one, use with PT100 directly. We can use convert from integer to double integer, and from double integer to real, and divide by 10. We will got the actual temperature. Okay, example, I will hit the channel number 1. Yes, let me hit channel number 1. Yes, let's see the temperature is the increase. Yeah, 47. Yes, and for channel number 2 I will hit also. Yes, channel number 2. So if I hit, yes, it will up also, right? Start increase, temperature start increase here. And for channel number 4, right, the new model of analog, I will hit also. Let's see. Okay, 27, 29. I will hit more. 47, right? Start increase. And for this one, for example, for Y, yeah, I will select, yeah, to 20 milliamp, so it will show 100 degrees Celsius. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also, to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much, and in the part 2 we will see you again. Okay, thank you very much again, and see you next videos. Bye bye. Go to part 2 about how to connect the PT100 and TC with the 2Y and 4Y transmitter to the analog input of PLC S7-300. Okay, in the previous video we already learned about how to link or how to config from analog input to the PT100 and TC by using the schematic manager to config and test it already. Okay, So today we will continue to part 2 about how to link all data to the HMI, okay, by using the WinCC Flexible 2008 for simulation and then download the project to the real of HMI, okay. So first let's open the existing project of Schematic Manager project that we already learned in the previous video, okay. So we can check and then online. Okay, we can online for monitoring the actual value of the temperature for each channel. Yes. So we need to show all these channels to the WinCC Flexible and HMI, right? So we need to create. Double click on WinCC Flexible 2008 and then create the empty project. And right now I will use panel, schematic panel, right? Okay, I will use MP 27710 touch, yeah, for my HMI for connect with the PLC. So let's click OK to create the new device of HMI. And then we need to create the new connection, right? Example PLC1 connection and connect with the communication driver is S7-300 400, right? So right now I will use Ethernet connection. So here is the IP address of my computer. Yes, 192.168.0.253, 192.168.0.253, and here is the address of PLC, yeah, IP address. So 192.168.0.1, right? IP address of PLC. And then we need to create the text, right? Follow the program of Schematic Manager. The first one is sensor number 1 PT100, so MD0. So let's go to text tab and create the sensor 1. Yes. And the data type is real, right? So real, and start from MD 0, okay. So we can comment signal of sensor number 1. Yes. Okay, sensor 1. And for sensor number 2 is MD20. Yes. Sorry, MD4. So next, sensor 2, MD4, signal of sensor number 2. And actually we can copy and paste here. So we can rename here to sensor number 3, and the address is MD8. so MD8, change this one to 8, change this one to 3, and for the last one we can also copy, copy, select copy and then paste here. So sensor number 4, and the address is MD12, so MD12, we will change this one to 12, sensor number 4, right? Okay, actually we can connect another sensors that we want. For for module number 2 we have a channel. It means that we can use 8 PT100 or 8 sensors. Okay, so right now just example, so I will use only 4 sensors. So let's go to screen, and then we can adjust this color to be background like this or like this. Yes, and then we can edit the text. Example, I will use text file. So example, show actual value of PT100 TC on HMI model MP27710A. Then we can go to property and then go to text, and then we can use the Tacoma ball and then 16. Okay, not enough, right? So we can use like this, and we can delete. We keep only HMI model, yes, like this, and we can delete. Okay, so we can increase the font size to be bigger than this, 22, right? And should be center and should be middle. Okay, so we can adjust the size that we want. Actually we can use the color, example yellow, yes, to be clear. Okay, and we need to create the format, right, for sensor. I will use IO file, yes. So we can create only one format, and then we can copy and paste. Example 999.99, yes. Go to text, go to Tacoma ball, and then use the 22, yes. And we can use the center and also middle, and use the color, right? Go to property, and this color I will use background, I will use black, and text I will use green, yes, like this. If we would like to set the color, we can set also. I already show in the previous video, yeah, show the alarm. So here we can use white like this. Okay, and then I will copy this text to be sensor 1, PT100, yes, and we can use white color like this, and for unit we can copy, yes, like this. Copy one more for C. C is capital. Okay, like this. Actually we can group. Okay, so sensor number 1 we already created. Okay, I will adjust to be like this. For sensor number 2 we can copy, yes, select and then copy like this. And for sensor number 3 we can also copy like this. Sensor number 4 can copy like this. Okay, and then we will change this one to sensor number 2, PT100 also, yes. Sensor number 2, it is the PT100, right? Okay, PT100. Sensor number 3, it is the TC. And number 4 is the PT100 also, right? Okay. So we can insert the text. For text number 1, I will use sensor 1. Let's browse the text. Sensor 1. This one should be sensor 2, and the option is only output. This one should be output also. Sensor 2. This one output also. Sensor 3. And this one sensor 4. Okay. And then we can save the project. Yes. Save to keep the desktop and go to TC testing. PT100. Okay. And then we can simulation, yes, before go to download to existing our HMI. So we can simulation to make sure the design is correct, yeah, properly before download. Okay, let's see right now. Channel number 1 around 26.7 degrees Celsius. Yeah, here. Channel number 2 around 100 degrees Celsius. Channel number 3 around 26. And channel number 4 around 25. Okay, so we need to download this project to the actual HMI, right? So let me connect the LAN cable. Okay, so right now I already connect the LAN cable from HMI to the PLC, and we need to download the project, right? For HMI, IP address is 192.168.0.2, right? So we can ping 192.168.0.2. Okay. Right now we cannot ping, right? So let me check the LAN cable again. Okay, so let me check ping again. One nine two dot 168.0.2, right? Okay, let's ping again. One nine two dot 168.0.2, right? Okay, cannot be right now. We can ping. Okay, we can ping, so we can download also, right? Okay. So before download, I will close the simulation. Yes. And we need to click the HMI to be a transfer, right? Let me show. So first we need to click to the transfer, yeah, like this. Actually, we click like this, yeah, transfer when we boot the HMI, yes. And then we can download the project, yes. Okay, can download like this. And we need to choose the Ethernet, right? And put the IP address of HMI. Example 192.168, right? 168.0.2, right? Like this. And then we can transfer and click yes to confirm. Okay. So we will got the project the same as the project on computer, right? Okay. So right now the channel number 1 show around 27, channel number 2 around 100%. So 100 degrees Celsius. So if I adjust this one, yes, like this. And if I hit another channel, yes, let's see, it will go up. Okay, hit another channel. It will go up also, okay. We hit another channel. Okay. So this is just example about how to create the project of HMI and then download to show the actual of temperature. Yeah, actually we can online like this, simulation like this, and we can see on the screen also, right? Okay. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Today I would like to show and share about how to read data from encoder by using PLC S7-300 and HMI HP30 with LF brand, yes. And I will use the software Semantic Manager and software HP Builder version 2.0 to configure the project of HMI and download the project to the HMI LS. Okay. And I will show step by step about how to wiring and how to create the block to read the data from encoder by using this input. Okay. So first I would like to explain a little bit about how to wiring the connection of encoder to the PLC input, because it's very important. If we cannot wiring the connection, it means that we cannot read the data from encoder. Okay. And I will use the LAN cable connect from my PC to the PLC, and then another port from the PLC I will connect to the HMI. Okay. And here's the encoder, incremental encoder, that I already connected the power cable and signal cable to the PLC S7-300 input. Yes. So let's go to see the drawing. Okay, here is the drawing detail that I already draw for easy to understand. So for here is the CPU 314C 2PN/DP, and here is the Profinet port or Ethernet port, and here is the Profibus port. Here is the switch on and off for turn on and off the CPU, and here is the H1 of analog module, and also not used right now. For terminal H2, right now I will use for connect from encoder, and here is the encoder, just example. So I will use 4 cables, 4 cores, yes, 1 core for supply, yes, to encoder 24 voltage, and here is the minus, and here is the plus, yeah, that connect supply for encoder, and here is the signal from encoder that will connect to the terminal number 2 of H2 terminal, and for terminal number 3 I will connect one more, because we can use for reverse and forward. It means that increase or decrease value, so we need 2 cores of cable from encoder. Okay, for positive voltage I will connect to terminal number 1 of this card, and for terminal number 20 I will connect the minus, yes, of 24 voltage. Okay, so please follow my drawing, otherwise we cannot read the data from encoder. Okay, so when we increase the encoder, the input will turn on, yes. So this is just summarize about how to wiring connection of encoder, yes. So let's go to our software to create the new project of Schematic Manager and HP Builder to download to the PLC S7-300 and HMI to read the data from encoder. Okay, so let's go. So first I will create the new project of PLC S7-300. So right click and then create a new folder, example encoder, HMI ls encoder. So open Schematic Manager, and then go to create the new project, file, new project, and browse to find the folder that we already created. Okay, HMI ls encoder, and here is the project name, example ls encoder, and then I will insert the object S7-300 station. Okay, and then I will create the rail, yeah, insert the rail. Let's go to the rack 300 and then create the rail, drag and drop here. And then go to the power supply, yes, go to PS 300, and then I'm going to add the CPU, yes. Right now we use CPU 314C 2PN/DP, version. And here is the IP address of PLC 192.168.0.1 and subnet mask 255.255.255.0. Then click OK first. And it has one more for one more card analog, yes, that I already insert because right now we don't use it, but I just insert it for analog input. So I will create one more. Otherwise, if we download to the CPU, it will fall because the hardware configuration must be matched with the software. Okay. So I will use SM300 AI, and here is the model number. And I will revise the input. The first one is RTD. The second one is RTD also. And the third channel is 4Y current for 220 milliamp. Yes. And we need to use the counter right here. Here is a counter. So to enable the counter, first let's go to channel. Totally we have 4 channels, but right now I use only one channel, so I will use channel number 0, and we need to enable this one. Yes, count continuously. Yes, and here is the address. Start from 816. Yes, and the next step I will explain about how to calculate to the convert to hexadecimal. Yes. So click OK, and then save the project. Yes. And we need to download the hardware configuration to the PLC, right? So first we need to manual the IP address of computer. So let's go to put the manual. Right now the PLC IP address, PLC IP address 192.168.0.1, right? So we will put the IP address of computer to be matched with the rank of the PLC. Otherwise we cannot ping. We cannot connect from our PC to the PLC, right? So I will put 192.168.0.253. So 192.168.0.253, and subnet mask is the same, 255.255.255.0. Okay. And we need to turn off the Windows firewall also. Otherwise we cannot connect. So right now we can use command prompt to ping 192.168.0.1. Yes. So right now we can ping from our PC to the PLC. So we will download. Okay. So right now we already download complete and successfully. So we need to create the block, yes, for read the data from encoder, right? I will use the ladder language. Okay. And I will use the library, yes, standard library block. Let's go to library and go to the standard library. And go to the system, yes, and find the SFB47. Here, SFB47, it is the count continuously. So drag and drop to our network. I will zoom a little bit. Okay, so this is we can comment from encoder and show value on HMI LS HP30. Okay, so I will use DB1. Yes, if we put DB1 here, it will create automatically here. Yes. And then we need to put the channel number. Yes. So here channel number 0, right? Because right now I just put the channel number 0. It means that I just enable for channel number 0 of the count continuously. Yes. So here I will put 0 because we use channel number 0. Totally we have 4 channels, right? So I will use channel number 0 first. And for LADDR, yes, we can use the address but convert to hexadecimal. Okay. So for the address here, it will start from 816, right? So 816. So we can use the calculator. So 816 convert to hexadecimal. It should be 330. Okay. So here we can put 330. So hexadecimal 330. And we need to show the value of encoder, right? So here count value. I will put another memory, example MD 0. Yes. So we can save the project and then download to the HMI, to the PLC. And we need to download all blocks also. Okay, and then open again, and we can online to see. Okay, and I will use the hand by increase the encoder and decrease. Let's see the signal. Right now I will increase. Okay, let me increase the encoder. Right, it's not working, right? Because of gate we not yet enabled. Okay, so I will enable the gate speed here. Otherwise it will not working, right? So we need to put the gate switch. Yes, with gate here. Example, I will put M 10.0 and then download again. Okay, and then I will turn on the M 10.0. Yes, I will turn on, so I will put true, and then let's test again. Okay, let me rotate the encoder again. Let's see the value is decrease and increase. Yes. Follow the rotation. Okay. Let's see the input is turned on. Yes. And turn off. So we need to show the value here on HMI, right? So let's go to I will cancel this one first. So let's go to create the project of HMI and then download to the HMI to see the status. Yeah. So first open HP Builder version 2 and then create a new project and let select the serial number of HP series. Yeah. So right now I use HP 30 TTA, and here is the marker. We can use another brand of controller that we want. So right now I will use Siemens AG because we use PLC 300 and I will use 300 and 400 by Ethernet, and go to communication, and here is the protocol. Yeah, so Ethernet, and here is the PLC IP address. So 192.168.0.1. Yes, so correct. So click OK, and then I will change this color to be background to this color. Okay, like this. And then we can read encoder by using the numeric display, right? So click here and then use the and here is the address of encoder of the value of output encoder. So here we have only IW, QW, TW, CW, MW, and DB, right? So we need to convert here to MW, but this one. So let me modify. Actually here we can use the move. I will move this one to MW. Example MW10. Yes. Save the project and then download to the PLC again. Yes. So here we can use MW10. Click OK. And for the format, we can follow this one, 16-bit. And here is the numeric. So we can use unsigned, decimal. And here is the number of display. It means that this one. Yes. If I increase, it has like this. Okay. The 1 digit. So normally I can use only 6 or 5 digit. And here is the decimal. Yes. So we can adjust the display to be good looking. Example, this one center, font, font size, Tacoma, example 26. Should be like this. So I will comment like this. Example, I will use text. Yes. We can adjust. Yes. And I will adjust the font size to be 28. Okay or not? It's so big, right? Okay, I will decrease to 24. Okay. Then this one link with HMI, LS HMI, HP 30 TTA. Okay. I will use yellow color. Actually, everyone can adjust the screen, that we want. And I need to use the one more button, one more switch for enable the switch gate, right? So let me choose the one more switch. Okay, switch bit. So I'm 10.0. So we need to put the address. So M 10.0, yes. And I will use the alternate because we need to click and then it will hold the signal. Go to display, go to library. I will use the library, go to all, then I will use this button. I will change the format, yes. Like this. And we can adjust, yes. Okay. And then we need to download this project to the HMI, right? So let me check the HMI 192.168.0.2, yes. So we can ping and then we can save the project first. I will save to desktop and then choose the, yeah, this one, encoder. Then I will download this project to the HMI. Yeah, click download and then go to setting, and here is the setting that we will choose the correct setting. So 192.168.0.2 is the IP address of HMI, and here is the network adapter of my PC. So click OK and then click download. So wait a moment for downloading the project to the HMI. Let's see now, downloading. Yes, finish. HMI will automatically reboot after finish downloading. Right now, starting up. Yes, open screen. Okay. So right now, let's see the value of encoder is 65. Yes. Let online the PLC. Yes. 65 also. So if I adjust the encoder, let me adjust the encoder. Yes. The value is not increase and decrease, right? Because we not yet enable the switch gate. So if I enable the switch gate, yes, then adjust again. Let me check the switch gate on or not. not on, right? So let me check again here. M10.0 momentary. Okay, I will change to this one and then download again. Okay. And we will test again. It's not on, right? Let me check. M10.0. That's correct. Let me download the block, all block again. I will change this one to M100.0. Yes. And then download again. Because here we use MW10. Yes. So let me adjust this one to M100.0 and then save and then download again. And we will test after we finish downloading the project of HMI to the HMI. Starting the HMI. Okay, finish and go to online and then check again. Okay, the switch gate right now 1, right? So we can increase the HMI. So I will increase. Yeah. Let's see the value is increase, start increase, and decrease. Follow our adjustment of encoder. Yes. Okay. Yes. Decrease. So here is just example about how to connect the HMI LS to PLC S7-300 and read the data from encoder. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Today I would like to show and share about how to link data from PLC S7-300 to HMI Schneider model GHO3502 by using the RS485 cable for link the data from the PLC to the HMI. And I will use the cable USB type B to download the project from the PC to the HMI and use the LAN cable for communication between PLC and PC to create the new project of Schematic Manager and then test with the HMI. In this section, I will detail about how to connect or how to assign the RF485 pin with the PLC port and with the HMI port. Okay. And in this section also, I will use Schematic Manager for PLC project and Visual Designer version 6.2 to create the project for HMI. Okay. So before go to create the sample project for test, I would like to explain about how to assign the pin for PLC and for the HMI by using the RF485 for communication. Okay, so let's go. So here is the PLC port. So we will use the male of RF485 and we use the resistance connect from pin number 6 to pin number 3, 390 ohm, and series with the pin number 8 with the resistance 110 ohms, and we will connect with the pin number 5 to parallel with the pin number 8 with the resistance 390 ohms also. And for the HMI connection side, we can connect pin number 6 with number 9. We can building, yes. Number 4 with number 8. Number 1 connect with resistance and parallel or connect with pin number 2 with the resistance 110 ohms. And we will use only 3 cores of cable. The first one is number 5, it is the ground, yes. Number 5 connect to number 5. Number 8 connect to number 7, yes. And number 3 connect to number 3, okay. So for the length of cable, we can use up to 5 meters, yes. And for the transmission rate is very important, yes. For S7-200 we use 9600 for PLC S7-200 and 200 Smart. I already showed in the previous lesson. And for PLC S7-300, we use 187500 for transmission rate. I will show on the configuration with the video designer. Okay. And for the HMI side, we use the female for connect with the COM2. Yes. So this is the main objective of this video, because we need to know about how to wiring the connection between PLC and HMI. Otherwise we cannot test. Okay, so everyone can follow this drawing. For the resistance, we not fix 390 ohm or 110 ohm. We can use the similar, yes, resistance, the similar, so we can test also. So now let's go to our software to create the new project for test with the data from the HMI and PLC. Okay, so let's go. Okay, so we will use Schematic Manager and Video Designer that I already installed in my PC. So I will create the new project, S7-300 connect with Schneider HMI. Okay, so first we will insert or create the new project on Schematic Manager. So open Schematic Manager. Right now I use version 5.6. Okay, so create the new project. I will put the project Schneider HMI and browse to find the folder that we already created on desktop. So here, and then click OK. And we will insert the hardware configuration for the CPU. In my slide, I will use the CPU 314C 2PN/DP. It has 2 ports of Profinet and 1 port for Profibus. Yes, so we can insert the Schematic 300 station. Okay, Schneider HMI. And then we can insert the rack for Schematic S7-300. So I will create the rack. And then we will insert the CPU to match with our hardware. Yes. So 314C 2PN/DP version 3.3. Okay. So this is the IP address of the CPU. So click OK. And here we must use MPI because we connect with the HMI. Yes. Property, yes. Let's see here. 187.5 kilobyte per sec. It is the transmission that I already explained in the slide here. Yes. So we need to choose the transmission rate the same as the PLC port. Yes. So this is the address. It will automatically create it. Yes. Anyway, we can change the address here also. Example, we can change to start from I0. So it will start from I0.0, and for the output we can also change to 0.0. Yes. So it will start from I0.0 until 2.7 and output Q0.0 until 1.7, and then save and compile the project. And we need download the project to the PLC, right? Download the hardware configuration. So I will connect the LAN cable from my PC to the PLC, and then you can check the IP address here, 192.168.0.1. So let's put the IP address of our computer. Maybe I put already, right? Let's check. So I will put 192.168.0.253. And then we can save and then download the hardware configuration to the CPU. So before download, we can go to set PC interface. So make sure we select the connection here, and then we can test. Okay, it works. And then let's go to download. So it will find the CPU automatically scan between PC and CPU. So wait a moment for scanning the address of CPU, and it will automatically detect when the PC detects with the PLC. Okay. Okay, so right now it detects one CPU that has IP address 192.168.0.1. So click View. To view the status of the CPU. Yes, and then click OK to download. Click OK to confirm, and OK one more time to stop the CPU. And right now the CPU is stopped and complete download, so we click yes to restart the CPU, and the CPU is running right now. And then we can create the sample logic to test with our HMI. So I will go to OB1, I will choose letter, okay. So we can command send data from HMI to PLC. So we can create the pull button stop, pull button start, and output. Yes, and here I will use M0.0. edit symbol, example stuff M1, yes, M0.1, example start M1, and I will turn on the output. So output we already changed from Q0.0, Q0.0, so relay 1, or motor 1, okay, and I will hold signal by Q0.0. So we can save the project and then download to the PLC, and we can online. Okay, so we can go to Video Designer to create the HMI and then download, and we will test with the PLC. So let's go to Video Designer, so double click to open. Okay, so we will create a new project. The project name I will put PLC S7-300 connection. So we can copy from here and paste, and we will choose the correct model of HMI. Yes, there are many models, so I will use HMI GHO series and choose GHO certified 02, the same as our HMI. Yes, so click next again, and add the driver of PLC. So I will choose Siemens AG and choose the schematic S7 MPI/PPI. So in the previous video we learned already about S7-200 series. So right now I will use S7-300/400 series. Okay, and then I will change the background of screen to this color. Yes, and then I will put the text. Okay, welcome to PLC S7-300 tutorial. Okay, then I will use the font size to be this size. I will use bold. Yes, and we will create the variables for connect with the PLC, right? So M0.0 is stop, M0.1 is start. So we can use variable, create the new variable and boolean. Example, stop relay 1. And this is a driver, yes, so we can choose. And here we can choose M0.0, it is stop, right? And insert one more for start, relay 1. M0.1. Yes, it is like this, the same as the address of PLC, right? And one more boolean for relay 1 status or motor 1 status, right? So I will put relay 1 status. So Q0.0, yes. And then don't forget check the transmission rate, yes, it's correct. And we'll connect to COM port 2 F485 for serial interface. You can save the project and then go to the screen and configure the screen, right? So I will use switch. Okay, I will put the stop button, stop R1. Okay, stop R1. And I will change the text color to be black and change the color to be red for fill the button. Okay, stop R1. And we have to copy to start R1. Okay, this one should be start R1. And then we will change the color to be blue. Yes. And we need to insert the relay number 1, right? So I will insert the relay number 1. Okay, we can use on off like this. So when the condition off, I will write with relay 1 off. And when it on, I will put relay 1 on. And for the font size, we can use the font size. And then we can use the style like this. Yes. Okay. And we can change the color. Voltage color, I will use black. And for the condition off, I will use the red color. Condition on, I will use the green color. Okay. So if we would like to turn on another relay, we can copy. So right click, copy, right click, paste. And then we can adjust the alignment. So I will change this one to be relay 2. This one should be stop relay 2, stop R2. This one start R2. Okay. So we need to create more for logic, right? So I will offline first and then insert the network. This one for control relay 1. And this one we can paste for control relay 2. I will change description this one to be relay 1. Okay. And then we can insert the push button stop, pull button start, output, and parallel to hold the signal. Yes. And this one I will use M0.2. It is stop relay 2, right? Stop R2. This one I will change to stop R1. This one I will change to start R1. Okay. And this one should be M0.3, right? So start R2. And this one Q0.1. So relay 2, right? Okay, this one relay 2 also, so Q0.1. Okay. And then we can save the project and download to the PLC and we can online. And then we can go to create the HMI. Yes. So let's go to variables, insert the boolean. So this one should be stop relay 1, stop relay 2. So M0.2. Yes, this one. One more boolean. Start relay 2. M0.3. And one more for relay 2, right? So relay 2 status Q0.1. Yes. And then let's go to screen and then configure the button and relay status one by one, right? Okay, first I will configure the stop button for relay 1. So double click, go to operation. I will use bit and use the momentary on. Destination, I will choose stop for relay 1. This one, double click, go to bit, momentary on, and choose the start relay 1. And this one, go to the variable and choose the relay 1 status. Okay. And for the color, for the label, right? We already put the text for the label. And for button stop relay number 2, can go to bit and choose momentary on also. Stop relay 2. Click OK. Start R2. Go to bit, momentary on. Choose the start relay 2. OK. And relay 2 status. Go to general variable. Go to relay 2 status. And click OK. Okay. For this one, we already changed, right? For on off. So when off, condition red. When on, condition green. Okay. So we can save the project and simulation a little bit before download to the HMI. Okay. And then we can connect the USB type B from the HMI to our PC. Yes, so I will connect. And then I will choose the visual machine. And we can download. Make sure we check the driver before download. So we can go to manage. Device manager. And then see here. HBTZ USB. It means that convert from the HMI to USB driver. Okay. So we can download. And check delete runtime data. And then download the project to the HMI. So take time a bit for download the project to the HMI. After that, we can test together. And I will drop the example project under my video so everyone can download and then see the example that I already configured or design the screen. Yes. Okay, finish. So we can go to the project of PLC and we can test with the HMI together. Okay, let's see the status of PLC is turned off. So if I push start button, yes, the PLC is turned on, and the status is show relay on. So if I push stop, yes, stop, start again, and the HMI will show the relay 1 and relay 2 is turned on. Yes. So communication between this cable and HMI is working perfectly. Yes. You can stop, start again. Yes, so it worked perfectly. So this is just an example about how to link the data or connect the data from PLC S7-300 to HMI Schneider by using the RS485 cable. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Today I would like to show and share about how to link data between PLC S7-300 to HMI Schneider GHO certified 02 via RS485 cable. And in this section I will use two softwares together. The first one is TIA Portal version 16, and the second one is Video Designer for create the new project of HMI and then download to HMI by using the USB Type B. We can download from our PC to the HMI. Okay. And I will use TIA Portal version 16 to create the sample program on the PC and then download to the PLC by using the PLC S7-300 CPU 314C 2PN/DP. Okay, and I will use LAN cable connect from Profinet port of PLC to my LAN card of my PC. Yes, and in this section I will detail how to use the software Video Designer version 2.6 with page 8, and we will create the sample screen and then test with the PLC. Okay, so let's go to our software. Okay, first one I will use TIA Portal version 16. So let's go to open TIA Portal. Yes, wait a moment for open the software, and then we will create the project together. After that we will download to the PLC. Okay, so first let's go to create the new project. Example link S7 link HMI 1. Yes, and I will go to save the project file. I will go to desktop and then create the new folder. Example HMI Schneider. Okay, and then click create to create the project, and wait a moment for create the project. It takes time a bit to create the project. Yes, so let's go to project overview. Yes, and then go to create new device. Okay, so right click and then create new device, or double click to add new device. So I will use the Simatic S7-300. Yes, let's go to choose the CPU. Right now I use CPU 314C 2PN/DP. Yes, version 3.3, and then click OK. It will create the project for us. Yes, okay, so when we use the CPU 314C 2PN/DP, we will got the internal I/O. Yes, internal digital and analog input and output. Yes, here. Yes, we will got analog output and input card, digital input and output card. Yes, here, and we will see the I/O address, right? But first let's go to see the I/O address. Right click and then property, So the input address will start from this is a analog, yes, analog address, and this is a digital address, yes. Digital input, it will start from %I 136.0 until %I 138.7, totally 32 bits. And for the for the output, it will start from %Q 136.0 until 137.7, totally 16 bits. Okay, sorry, okay, 16 bit, yes. And we will use this output to show the signal on the HMI, yeah, when we push any button. So we can download the hardware configuration to the PLC first, yeah. So go to right click and then go to compile first, yeah, to check the program, yes, hardware configuration has error or not. So we must compile the program before download to the PLC, okay. And then we can download the hardware configuration to the PLC first before we create the logic for test, yes. Okay, so I will search the device because I already connected the LAN cable from my PC to the Profinet port of PLC S7-300. Okay, so right now it detects one CPU 314C2PN/DP, and here is the IP address of the PLC. So we can load the hardware configuration. And then we can stop the CPU, yeah. During we download the hardware configuration, the CPU will stop, yeah. So stop the CPU, and when finished we can start the CPU. The CPU will start, yes, okay. And right now the hardware configuration is already downloaded from our PC, yes, to PLC. So let's go to create the sample logic for test with the HMI. So let's go to program blocks and then go to OB1. Okay, so we can command on the network, example create push button control from HMI Schneider, yes. So here we can use NC, yes, NO, white, and we can hold the signal, yes. Basically we can learn from the basic like this before go to advanced, yes. So here I can use example M0.0, example stop command, yes, stop CMD. And here example M0.1 start command, so start CMD. And here we will use the output, right? So to see the status we use output, yes. and output it will start from Q136.0 right here. So we can use the Q136.0 example output 1. Yes, output 1. And then we can hold the signal, so Q136.0 also. Okay, and then we can save the project and then compile. Okay, compile successfully, no error occur. And then we can download the logic to the PLC. Yes. Okay. Basically, we no need to stop, but in this time I stop the CPU again. And then start the CPU back when we finish. Okay, and then we can online. Okay, right now we already complete the logic for test the sample program. So let's go to create the project of HMI. Yes. So I will use another window to create the project of Video Designer to download to the HMI slider. So first let's go to open the Video Designer. And then let's create the new project. Yes. And we will create the project name, example link to TIA. Click next. And then here example PLC S7-300. And we need to choose the model of HMI. Yes. In this type, there are many types that we can use. But I will use HMI GHO series because it matches with my HMI. Yes. And then this is the series of my HMI. So GHO 3502. Yes. It's very important in this step. If we select the incorrect type of HMI, we cannot download to the HMI. Okay. So be careful in this step. Choose the correct type of HMI and model. And then click next. Click next again. And here also very important, we can add the devices. So right now I will use Siemens AG. There are many drivers that we can use. Example ABB Automation Manufacturer, Emerson Process Management Manufacturer, Emerson Corporation, Rockwell Automation. Okay. Right now I will use Siemens because we connect to the PLC S7-300. And I will choose the S7-300-400 series. Yes. And then click OK and finish to create the project. So we will got the sample screen. Yeah. In this screen we can change the color background and other color that we like. Yes. Example I change to this color. Yes. And here we can use the text. Example welcome to PLC S7-300 and TIA portal tutorial. Okay, and for the font size we can change here. Yeah, example I will change to the side design. Yes, so we can change and then we can adjust the area, yes, that we want. Okay, example we can change like this. Yes, and for the text color we can change the text type that we want, the text color that we want. Yes, so we can change like this. And for the push button, yes, push button start and stop from the HMI. Yeah, we will use this address. So start is M0.1, stop M0.0, and for the output is Q136.0. Okay, so we can use example. We can go to create the variables. So go to variables tab. Here double click the variable. So here we can use boolean example. I will insert the boolean and we can create as stuff. Okay, data type is boolean and I will use external. Yes, and here is the driver. Yes, and here is the address that we use. So M0.0, right? It is stop button. And we have many functions. Example, if we would like to lock to group 1, we can lock. Yes, so I will create one more boolean. Yes, example start, it is the boolean also, and we use external because we link from the PLC. And here is the address. So M0.1, it is start. Yes, and one more, it will show the status, right? So I will choose boolean one more, example output 1. Yes, it is the eternal and it will start from Q136.0, right? Okay, 136.0. So we can type 136 and then choose 0. It means that 136.0. Okay, so right now we already created the variables. So let's go to screen and then choose the button here. Okay, I will choose the stop button. Okay, and here we can choose the source, and here we can use bit, right? Because we use boolean and we use momentary on. Yes, and here we can choose the variable that we already created. So I will choose stop. Yes, and I will choose the format 002. Yes, and here is the color. So we have many color that we can use. Example, for the button we can use the color on and off. Yes, so here we can OK first, and we can go to double click and then go to color, and here is the switch 1, right? Switch 1, it means that stop button, so we can go here. Frame color, and for the label, for the label we can choose another label, example stop. Yes, and for the font size we can choose this size. Yes, and it will become like this. So for the color, text color, I will change to red. Yes, sorry, change to black color. Yes, and for the push button, I will change to blue color. Yes, like this. Okay. And for the start button, we can copy, yes, and then rename here. We just choose start, right? And for the color, I will change to be blue, and change this one to red because it is the stop button. Yes, I will change to red color, and this one blue color. Okay, and this one I will rename to start, and the font size is the same. So right now we have start and stop one. And then we can choose the lamp for show the signal of the output, right? Example lamp 1. Okay, I will choose this one. So we will use the color animation, right? So it is the output one. Yes, and the color I will change. When off, I will show the red color, and when on, I will show the green color. Yes, and for the label we can use also example when the status on. Example, we will show running. Yes, running. Yes, label running. Okay, so on this color and off this color. Label is running. Yes, or we can use bold. If we would like to change the size, we can also choose this size. Yes, it will come like this if we change the size of the button, sorry, of the lamp. And we can change another color that we want. Yes, here. So I will choose like this first, and then we can go to the configuration before download to the HMI. Yes, so the first we can go to config the baud rate. Yes, it's very important. If we choose another baud rate, example 9600 or 19200, we cannot communication between PLC S7-300 and this HMI, right? So we will choose 18750, yes, and choose the COM port 2 RF485, yes. And for another parameter, we can use default, yes. And we can go to the project and then go to option, general. So this is a download option. If we choose the file system, we can download to the USB, and then we can store the data to the HMI. Yes. So right now I will choose USB first, because I download directly from my PC to the HMI. Yes. And here is the option. If we choose the include edit the project, next time we can upload the program, upload the file from the HMI to use. But when we uncheck like this, we cannot upload the project file from the HMI. Okay, so I will include the editor project. Yes, and then we can save the project and then download to the HMI. Yes, I will download to the HMI. Before download, we can simulation to see the status of HMI first. So when we download finish, it will come like this. Yes, so we can download. During download, be careful, don't turn off the HMI. Yes, turn off the power of HMI, otherwise it will error. Yes, the runtime error. So right now, downloading. Okay, right now we already downloaded the project to the HMI, and then we will go to see the status of the PLC. Yes, and let's test together. So right now the PLC is online. Yes, so let's test the pull button. Okay, right now I will put the start. Yeah, let's see the output is turned on. Yes, and the color is show also. Yes, and if I push stop, yes, the output of PLC is turned off, and then color change to red color. Yes, so it means that communication between PLC and HMI is working. Yes. So next step we will create, if we would like to set point the value from the HMI, yeah, we can also do it. And then first let's go to create the data block. Yes, so right click and then create the block. Yeah, create the new block. And I will choose the data block. Yes, and then choose the automatic to add the block. Yes, we will add like this. Example, we would like to calculate the value. Example, value 1. It is the real. Example, I will choose real for data type. And then set point, can set point also enable. And example, value 2. I can set point also. It is real. Value 3. I'm no need to set point because it is the output. So if we would like to use the value 1 plus value 2 equal value 3, yes, we can also do it. So I will compile first. Okay, so it will start from db1 dot dbd0 dot dbd4 dot dbd8, right? Okay, so let's go back to our ob1. So here example, add value 1 and value 2 equal value 3. Okay, so we can use add, yes, enter, and then I will add real, right? So I will choose real. Yes, and here is the data block value that we already created, right? So I will use data block 1 value 1 right here, and for this one I will use data block 1 value 2. Yes, and here is the result, right? So result we can use data block 1 value 3. Yes, and then we can save the project, compile. Okay, successfully, no error occur, and then we can download to device also, because we just create the data block 1. Yes, and then we can online. Yes, okay, so we will got db1.dbd0, db1.dbd4, and the result is db1.dbdh. Yes, so let's go to our HMI program. Okay, so I will adjust this one to be like this. Yes, maybe I will change the color of the text to be black. Yes, like this. We can design the style that we want. Yeah, it is just example for communication, so everyone will design the same style or another style that you want. Yes, so I will use value. Yes, so value is number display here, so I will use value 1. Yes, we can also create the value variable from here. Yes, example, I will create the plotting. Yes, and here is the display digit that we will put. Example, I will put 6 digit, and for the decimal place I will put 2. Yes, and here is the enable input, so we can set point. Yes, and it will come like this: 1 2 3 4 5 6.12. It is the format. Yes, and for the font size we can use another size that we want. Example, I will use this size. If you would like to use bold, we can use like this, so it will come like this. It's so big, right? Okay, we can use like this, and we would like to design another style that we want, so we can use like this and go to the color. Yes, we can choose take color. Example, I will change to green. Frame color. Yes, frame, it means that here I will use white, and for the plate color I will use black. Yes, it will come like this. Input type we already enable mode, right? Because we need to set point. Yes, so that's good. And for the variable, we can go to create the new variable from here also. So create the new. Example, value 1, and I will choose real for data type. Yes, and here is the device. It means that we connect to PLC S7-300, and here is the data type address that we choose. So I will choose db1.dvd0. Yeah, it is the address of this one. Yeah, db1.dvd0. So db1.dvd0. Okay, then click OK. OK again, and OK again. Yes, and for the value 2 and value 3 we can also copy from here. Yes, so I will right click, copy, right click and paste. Yes, and this one I will create the new variable. Yes, and for the format I will keep the same as the value 1. Yes, so let me create the new variables. Example, value 2. In here we can also create another variable that easy to remember. Yes, so I will use db1.dvd4, right? Value 2, and then click OK. OK again, and this one will change to value 2. Yeah, this one value 1, and this one value 2, but the format I will keep the same. Yes, and we also keep the input mode, right? Enable, because we need to set point also. Okay? And we need to put the result, right? So result no need to input. Yeah, I will uncheck this box, and for the variable, we can create the new variable, example value 3, and the address will start from db1.dbdh, yes, this one, yes, db1.dbdh, yes, so db1.dbdh, it is value 3, yes, that's okay. So for text I will use plus, yeah, and then I will use the font size like this, and then we can adjust. So this one plus this one, and then equal this one, right? So if we know the basic create, we can also create the project for our machine, yes. So basic is very important, yes. So please follow me step by step. Okay, so this one plus this one equal this one, yes, and then we can save the project and make the simulation to see the status before we download to the HMI, yes. So that's good, and then let's download to the HMI again. Okay, click yes to confirm download. Yes, take time a little bit during download this project to the HMI, yes, and be careful, don't close or don't turn off the power of HMI, otherwise the runtime will be error or damage the software of HMI, yes. So be careful when we download, don't touch anything such as power and another screen of HMI, yes. Okay, so right now we already downloaded the project to the HMI, and then we can go to see our PLC, yes. So right now 0 plus 0 equals 0, right? So let's test together. Okay, 0 plus 0 equals 0. Example, I put this 1, so it equals 1, and the PLC is 1 also. Example, I put 1 2 3 dot 1 2 3, it will equal 1 2 3 dot 1 2, yes, because we put the decimal place only 2, and this one, example, I plus 44 125 dot 25, it will show like this, yes. So that's good, working properly, yes. So this is just basic about how to set point and show the result on the HMI, yes. And I have one point that need to show to everyone also, because we need to use also, yes. Example, we would like to set the timer, delay timer on or off, or timer path from the HMI. We can also create, right? Okay, so example, set timer value from HMI, yes. So basically I will create the timer on. Yes, so I will use timer on. Yes, and this is a timer on. Yes, so default I will use like this. So if we would like to control the output delay on, we can also set from the HMI, right? So basically we can set point the HMI by using like this. Okay, I will show this step first, and then after that we will convert this one to another step. Okay, so db2 IEC db2 dot pt, right? And this one IEC2 dot et, right? Okay, and then I will use M0.2 for enable the timer. Example, I will use M0.2, and this one example enable timer. Yes, and then I will control the output. Example, I will turn on the output Q136.1, right? Because it is continue from the Q136.0. Yes, so this one we can rename as output 2. Yes, and if we would like to turn on another output, we can also parallel with output. Example Q136.2, it is output 3. Yes, yes, and then we can also turn on another output. I will turn on file output, yeah, for example. So Q136.3, and this one should be output 4. So output 4, and this one Q136.4, it is output 5. Yes, and this one Q136.5, it is output 6. We comment like this for easy to understand our program. If we have any project, we can comment like this. Yes. So if I enable the timer and the setting, yes, the timer equal setting, it will turn on this output, right? Okay. So we can test like this first. So we can save the project and then compile the program. So error 1, yes, IEC count which one? It's not possible in target, right? db2 let's compile again. Timer, this one it is timer on, right? Okay. DB2, right? Okay. So it's error 1, yes, because we write the logic is incorrect. Normally the output we cannot parallelize this with the timer, yes. So if we would like to turn on another output, we can use like this. So I will copy this Q (136.1) to here, and then I will cut this network and then paste here. Yes, and then try to compile again. We will got no error, right? So we cannot parallel with the interrupt this one, yes. So we can save the project and then download to the PLC, yes. Finish, and then we can download all to PLC. And then start the PLC again. And then we can online here. Okay. So if we enable the timer, and then we can set the value of timer PT here by follow db2.dbd2. It will turn on the output, and then the output here it will turn on another output. Okay. So to create the HMI, we need to use the db2.dbd2, and to show the status of timing, we can use db2.dbdh. Okay. So let's go. So I will add more, yeah, the screen, right? So we can copy from here. So this one, it should be set the timer, right? So I will create the text. Set time. We can use bold, and for the text we can use another color. Example, I will use yellow color, and for font size we can use this size. So we have set timer, and we have show timer, right? So I will adjust here, copy one more, This one should be so, or we can write timer status. Okay, time show. We have time set and time show, right? And then we have the enable button, right? So I will put like this. Okay, it is the millisecond. If we write like this, it will come to a millisecond. The unit is millisecond, right? So I will change the color to be white. And this one is millisecond also. Yes. And we need to create new variable, right? And for the address is db2.dbd2 and the time show db2.dbdh, right? So let's double click. We need to enable the input, right, for this one. And I will create the new. I will use integer and create the new. Actually, we can create the variable from here. Yes. Example set timer, and it will start from db2.dbd2, right? So db2.2, yes. db2.dbw2, right? It is the double integer. Yes, I will choose double integer. Yes, timer set, and I will show the only 6. Yes, 6 digit, or we can use 8 digit. Yeah, because it is millisecond, right? Okay, and for this one we no need to enable the input because we just show the signal. Yes, so I will put 0, and this one put h also, an integer, and I will create the new. So example time show, it is double integer also. Yes, and for the address is db2.dbdwh, right? This one. Yes, db2.dbwh. Yes. Okay, it will come like this. And we have the push button, right, or toggle the input for timer here. So we need to enable. So I will copy this button. Yes, copy and paste, and we can write enable timer, I will adjust the size a little bit to be like this. Yes. And I will change the color to be, maybe I will use this color. Yes. Enable timer. And we need to create the variable also, right? So the address is start from M0.2, right? And output Q136.1. So M0.2, I will create the new variable and I will choose toggle because we need to one click and then enable the timer. Yes. So I will create a new variable, example enable timer, and address is start from M0.2. Yes. So M0.2 here. Okay. And then click OK. And we need to show the status of the output also, right? So we can copy from here. Actually, we can also draw, the new one from here. Example, I will show 5 output, right? So one output, it is the bit. Sorry. We will choose the lamp. Yes. So I will choose like this. And for the style, I will use this style or this style. Yes. Example, this one output 2. Because output 1 we already use, right? So output 2. I will create the new example output 2. And the device is start from Q136.1, right? So address will start from 136.1, right? Okay. Yes, it will come to output 2. And I will use this style. And for color, when off, I will show red color. And when output on, I will show blue color, green color. Yes. And then click OK. Okay. And if we would like to use the text, example show on or off, we can also use the text. Okay. This color on or off, right? Okay, we can use the text. Can use like this, yeah. And we can enable, yes, the option here. Example value position, color. So right now we would like to show the value, right? So I will enable the value. Yes. Boolean. Yes. So when on, I will show on, and when off, I will show off. And the text, I will use the output, this one, right? Yes. So when output on, it will show on. When output off, it will show off. Okay. And for the size, we can also adjust the size. Yes. Okay. Can use like this. And for the color, I will use the black color. Yes. And then we can copy to another 4 button, sorry, 4 lamp. Because we have a total 5 lamp, right? For when the timer is reaching, and then the lamp is turned on, right? So we can adjust to be 5 output. Okay. We can put like this first. It is just example, yes. So everyone can design the style. Because we will start from basic first, yeah. Okay, so I will adjust this slide, yeah, this take a little bit to be center with this output, because the purpose is turn on this output when the timer is racing, right? So for output number 2, okay, we will create the variable from here, yeah, easy to create. Example boolean. So this one output 3, and the address is Q136.2, right? Copy and paste. So output 4, this one should be .3. Paste again. Output 5, .4. Paste again. Output 6, .5. Yes. So until .5 or .6, right? We can check again. So it will start from .2, .3, .4, .5, and .6. Yeah, totally 5, right? Okay, so we can go to our screen. Yes. So this one we can configure step by step. So this one should be output 3. Yes. And this one should be output 3 also. Then we can adjust. This one should be output 4. This one should be output 4. This one output 5. And for the lamp is output 5 also. This one output 6. And for the lamp is output 6 also. Yes. And we can save the project and we can simulation before download to see the status of screen. Yes. Okay. And then we can download the project to the HMI again. Yes, the project is starting downloaded. So wait a moment for downloading the project to the HMI. And next step I will show how to set the unit as second. Yes. Okay. We will go step by step. It's just the basic. Okay. So right now we finish download. But the font size is very big, right? So I will change the size to be smaller than this. Example like this. Edit text, and then can you design? But we can use the option for bold. Yes. This one also. It's very big. Okay. We can change to bold. This one also. Change to bold. And this one also change to bold. Yes. And for this one we can also use the text, example running or stuff. Yeah. So this one output 1, right? So we can copy the variable and then copy from here, output 1, and for this one I will delete the label. So when we push the button on, it will show the running, right? So running, and this is stop. Yes. and then we can save the project and then simulation again. Okay, and then we can download the project to the HMI again, because we just revise some size of the lamp. Please OK, yes to confirm. So wait a moment for download the project. Okay, download it now. Okay, finish. So we can go to our PLC, yeah, and test together. So I will zoom a little bit, zoom out, for easy to see the status. Yes, like this. So let's start together with me to test. So first we need to set the timer. Yes. So example, I set 5000. It means that 5 seconds, right? Because the unit is millisecond. Yes. So if I turn on the enable the timer, it will count. After that, output will turn on, right? And change the color, and this one is change to on also. Yes. So if I disable, it will off, and enable again, it will count again, and then turn on the output again. Okay, so actually we can also create the more logic for set the second. Yeah, I will show. So if we would like to set with the second from the HMI, yeah, unit is second, we can follow me like this. I will insert one more network. Yes. So this one I will use the multiply. I will use multiply and multiply double integer. Yes. So I will multiply this one by 1000, and then create the temporary variable. Yes. Example timer 1. Mul. Yes. And the data type is time. The data type should be double integer, right? It's time. And then here I will use timer 1 mul. And then this one is timer 1 mul also. Yes. Actually we can drag and drop this one also. Yeah. So I will multiply by 1000, and then here is output from multiply, and then for this one I will keep the same. Yes. So let's compile our program and then download to the CPU, and we will go like this. Yes. So if I set 5 from the HMI, I will multiply by 1000, and it will go to set here 1000. It means that 5000 here. So 5000 equal 5 second. Yes. So we will go to revise our HMI. So this one should be second, right? So second, and for this one I will keep the same, and for this one I will divide by 1000. Yes, just put like this, and then download to the HMI again. We will got second. Yes, set second from the HMI. Okay, wait a moment for download the project to the HMI again. After that, we will test together, set by second, and let's see the result together. We can also use apply the basic, yes, to be advanced if we have the basic. Yes. For me, I also start from the basic. Okay, so right now it already download. So let's go to our PLC, yeah, to see the status. So right now it's 0, right? So let me set the timer. So if we set 5, it means that 5 seconds, right? Set 5, it means that 5 seconds. So multiply by this one is db2.dbd2, right? So we will keep this one the same as before. Okay, so let's test together. So if we try to set example 5, we cannot set, right? Yes, because we need to revise the logic. Yes. So I will create one more variable in the db1. Yes, before we can set. So I will create the set timer. Yes, and the data type is time. And we can compile. Or here we can use int, yes, double integer. And then go to OB1 again. And here we can instead by data block 1 set timer, yes, and then we can save the project and then compile and download to the CPU again. So this one okay, we can override. Okay, download finish, and we can online to check. Here becomes 0, right? And then we will go to revise the HMI. It will set by db1.dbd12. Yes. So db1.dbd12. I will change this one to be db1.dbd12. Yes. And we can recheck here, set timer db1.dbd12. Okay, and then we can download to the HMI again. Yes, to confirm. So wait a moment for download the project to the HMI. And then we will test together. Take time a little bit for download. Okay, right now finish download, and then let's go to see the status here. So right now it shows 0. So let's try to set the timer. Example, I set 5. It will 5000, right? It means that 5 seconds. And let's start for test. It will count 1, 2, 3, 4, 5, and output is on. Yeah. If we would like to adjust to be 10, yes, and then try to start again, enable, it will count 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Output is on. Okay. So normally we set as with the second. Yes. So this is just an example about how to link the data or control the data from the HMI to the PLC by using the Schneider HMI and PLC S7-300. And for the software, we already use the TIA Portal version 16 and VGO Designer version 6.2 CV page H. Yes, I hope this video is just the basic for everyone. Yes, before come to advanced. Yes, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye.